Dr. Muhammad Nur Cahyadi and also Dr. Warma Dewanti as the Head of Research Center for Infrastructure and Sustainable Environment of ITS. Last but not least, I would like to greet all participants of this seminar. Welcome to the International Conference for Sustainable and Resilient Coastal Management 2020. This International Conference for Sustainable and Resilient Coastal Management is conducted with collaboration between 3 different research centers in ITS. Research Center for Maritime Technology and Earth Science, Research Center for Infrastructure and Sustainable Environment, and also Research Center for Disaster Mitigation and Climate Change. This conference takes the general theme of sustainability and resilience of coastal management, considering that Indonesia is an archipelago country, and most of the human settlement and activities are actually located in the coastal area. I would also like to mention some interesting facts regarding this conference, including around 30% of the participants submitted their paper are actually coming from countries outside Indonesia. They're coming from 9 different countries, including Malaysia, Thailand, Vietnam, the Philippines, Australia, Japan, Taiwan, China, and India. So hello for all participants from around the world. For today's agenda, I would like to share some points first. So here, first we will hear some opening remarks, and then we will have the first session, which is morning session, followed by question and answer. And then we have short break after that. We will have parallel session at noon, followed by short break. But during the parallel session, we will have a lunch break in between. After that, we will have afternoon session, followed by question and answer. And at around 5 p.m., we will have closing ceremony. So my name is Firda. I will be accompanying you throughout all session today. So if you have any question or any tech problem, you could always drop your question in the chat box, and then we will help you as soon as possible. I would like to inform you one more important thing, that this conference is also being recorded and also live streamed through our YouTube channel. Also, please make sure that you have the latest version of Zoom app in order to gain the most access for our program. Otherwise, you cannot access our break room during the parallel session. So make sure that you are signed in to your Zoom account. So for the first speech, I would like to invite Dr. Muhammad Nur Cahyadi as the chairman of this SCRM conference to deliver an opening speech. Okay. For Pak Nur, the floor is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning for all participants, dear honor professor and researcher around the world. I would like to greet our Honorable Vice Rector for Research, Innovation, Cooperation, and alumni of Institut Teknologi 10 November, Bapak Dr. Bambang Pramujati, our Director of Research and Community Service of ITS, Bapak Dr. Agus Muhammad Hatta, and also our honorable keynote speakers in this morning session, Professor Kensuke Fukushi from the University of Tokyo and United Nations University Institute. Ohayo gozaimasu, Professor. Actually, I graduated from Japan too. And also Professor, our colleague in ITS, Professor Iketut Arya Priya Utama as the Head of Research Center for Maritime Technology and Earth Science. Also our colleague, Dr. Aji Pamungkas as the Head of Research Center for Disaster Mitigation and Climate Change. Also our Head of Research Center for Infrastructure and Sustainable Environment of ITS, Ibu Dr. Warma Dewanti. And I would like to welcome to the International Conference for Sustainable and Resilient Coastal Management 2020. And also, as the head of steering committee, Professor Joni Hermana. Good morning, Professor. Our Conference of Sustainable and Resilience of Coastal Management, this is a collaboration of 3 of the research center in research and community service, which is Research Center for Marine Technology and Earth Science, Disaster Mitigation and Climate Change, and the Infrastructure and Sustainable Environment. Our topic, there is some subtheme, there is integrated planning of coastal area, technology and management, geomarine and mapping, marine technology, marine and coastal area pollution, conservation of coastal area, climate change, environmental and hazard mitigation, community resilience and empowerment, green and clean technology, sustainable construction, disaster management, and environment monitoring and sustainability. As Bunisal talked that there is around 10 countries include this joint international seminar. So we would like to say very thank you to our participants, our colleague from Taiwan, Mingxin University, from Philippines, University of Santo Tomas, from Malaysia, University Science Malaysia and University Teknologi Mara. Also our colleague from Charles Darwin University in Australia, Ho Chi Minh University in Vietnam, University of Geoscience from China, Shibaura Institute of Technology from Japan, Chitkara University from India. Also our keynote speaker in the afternoon from Hazard University in Netherlands, Harriet Watt University in UK. And also would like to say thank you very much for our colleague from Badan Informasi Geospasial, Universitas Brawijaya, ITB, Undip, UGM, ITK, ITERA, UII, UNPAD, Universitas Komputer Indonesia, and all participants. Also in, of course, Institut Teknologi 10 November ITS. Our paper conference will be published on the IOP Scopus Index. And we would like also thank very much for Directorate International Affairs of ITS, DKG, for the international participant contribution. Also funding for Directorate of Research and Community Service, and also all of the organizing committee and steering committee. We hope we will make strengthening international collaboration. Then we would like invite Bapak Dr. Bambang Pramudjati to open this international seminar. Good luck and enjoy this international seminar. Hope we will get very good result and publication. Thank you very much again. Assalamualaikum warahmatullahi wabarakatuh.
Okay, so now, thank you very much, Pak Nur, for the speech. Now we would like to invite the Vice Rector of ITS for Research, Innovation, Cooperation, and Alumni, Dr. Bambang Pramudjati, to deliver opening remarks and also to formally open this conference. Pak Bambang, the time is yours.
Pak Bambang is still in mute?
Ya, enggak bisa unmute sendiri.
Yes, already.
Enggak bisa unmute sendiri.
Yeah,
Oke,
already.
Thank you. Oke, selamat pagi. Suara saya bisa didengar ya? Good, oke. Thank you. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, salam sejahtera buat semuanya. Honorable keynote speakers of this conference, Prof. Thomas Wagner of Heriot-Watt University, UK, Prof. Kensuke Fukushi of the University of Tokyo, Japan, Prof. Iketut Priya Utama of ITS, Head of Research Center for Marine and Geoscience and Technology, Dr. Lilian Gelling of HC University, Netherlands, Dr. Aci Pamungkas of ITS, Head of Research Center for Mitigation, Disaster and Climate Change, and honorable guest, Dr. Muhammad Hatta, the Director of Research and Community Services, ITS, Dr. Warma Diwanti, Head of Research Center for Infrastructure and Sustainable Environment, and Dr. Nur Cahyadi, Deputy Head of Research Center for Marine and Geoscience and Technology, as well as the Chairman of this ICSCM 2020. Our colleagues here, so there's Prof. Johnny Hermana of ITS, Prof. Anseta of the Philippines, also Prof. Wang of Taiwan, and as well as Prof. Nur Aizam of Malaysia. And for sure, distinguished guests, ladies and gentlemen, all participants of this conference. Very good morning to all of you. Praise to God the Almighty for the health and the opportunity that are given to us, such that we all have the opportunity to virtually meet in this morning event. It is a great honor for me to stand here to welcome you to the International Conference on Sustainable Coastal Management 2020. First of all, I would like to convey our sincere gratitude to the keynote speakers for your time and effort to join and share your valuable experiences to all participants within this conference. Appreciation also goes to both steering and organizing committee who have worked their best to organize and run this event successfully. Ladies and gentlemen, this year, ITS, as the leading institution in science and technology in Indonesia, is celebrating its 60th anniversary. The theme of this year's anniversary is Technology for Prosperity. To support this event, the Research Center for Marine and Geoscience and Technology, in collaboration with the Research Center for Infrastructure and Sustainable Environment, as well as the Research Center for Mitigation, Disaster and Climate Change, are holding this international conference with the theme of Sustainable and Resilient of Coastal Management. As one of the biggest archipelago countries in the world, Indonesia has many resources in the coastal area. It has been a very favored settlement area for human population since the early civilization due to its provides abundant marine resources, fertile agricultural land, and ease of transport and trade of goods. This condition for sure has led to high population density and rapid development rate such that it has environmental consequences. This area becomes vulnerable in terms of environmental quality degradation, poverty, disaster, as well as the climate change impact. ITS, as one of the world-class university, takes an action role in the development of science and technology, especially in the field of marine technology, information and communication technology, and robotics. Automotive and industrial design that is environmentally sound through international research activity. One of ITS aims and responsibility is to develop research and technology to support sustainability and resilience in coastal area. This conference is one of the contributions of ITS to showcase many research and innovation that could assist in managing and overcoming the problem and challenges in coastal area. Ladies and gentlemen, hope that you all can take the benefit of being here in the conference, learn from each other, especially from the keynote speaker, share your experiences, and build the network for the future. Finally, on behalf of the organizer, I would like to apologize for any inconveniences due to our services or action during the conference. By saying out Bismillahirrahmanirrahim, I officially declare that this conference is open. Have a fruitful discussion and enjoy the conference. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Pak Bambang, for the opening remarks. Now we would like to continue with having a picture together. So therefore, I would like to ask everyone here to please turn on your camera so we can have a nice pictures together, I would like to ask my colleagues to have a screenshot. That will be perfect if you could turn on your camera, and then we will have a group picture together. So although we are sitting in different places in the world, I hope we could still have a nice group picture together. Okay, is that enough? Okay, one more. Okay, thank you very much. So now that we are officially started our conference, we will proceed with our morning session to hear presentation from our keynote speakers. Therefore, I would like to invite again Dr. Muhammad Nurchayadi as a moderator for this morning session. And then I would like to read out a bit of biography about Bapak Nurchayadi. So he's an associate professor and lecturer at the Geometric Engineering Department at ITS. He lectures undergraduate and master study program. He earned his PhD in 2014 from the Hokkaido University, Japan. Some of the subjects he teaches include Global Navigation Satellite System Survey, Global Geographical Information System Application in Hydrographic Survey, Physical Geodesy, Research Methodology, and then Satellite Geodesy, Satellite Altimetry, and also terrestrial mapping. He currently serves as Deputy Head of the Research Center for Marine Earth Science and Technology, Directorate of Research and Community Service of ITS. His research interests are the development of low-cost GNSS and also ionospheric disturbance analysis, which are applied in geomatics such as measuring land parcels, mapping using UAVs, mapping boundaries, and also hydrographic survey. For Pak Nur, the floor is yours.
Thank you very much to Nisa for time. Then we go to the main keynote speaker today. I would like to invite Professor Ken Fukushi. Before, I would like to share the CV of Professor Ken Fukushi today. Professor Ken Fukushi, Professor and Vice Director, Institute for Future Initiative, Department of Urban Engineering, Graduate School of Engineering, Graduate School of Frontier Science, the University of Tokyo since 2013. He got the PhD in Civil Environmental Engineering of the University of Utah, USA. Academic Council member 2016, academic program in 2019, member Engineering Academy of Japan, associate members and Council of Japan, also visiting professor. Now he has very good research interest about health risk assessment, hazardous waste management, global environment, water management, social psychology, behavioral economics, energy and economic, island study, climate change. Oh, this is very good in Indonesia and Vietnam. So he will deliver a speech very nice, I think. Okay, Professor Ken Fukushi, you will share your presentation or I will share your slide, which is whether you prefer. Professor Ken, could you hear me?
Yes, I would like to share a presentation by myself, please.
Oh, okay, good. So I will stop share. Okay, time is yours, Professor Ken Fukushi. Okay.
Yes. Am I sharing the right one?
Yes, good.
Okay,
Very
good.
nice.
Thank you, Mr. Chairman. Thank you very much for a very kind introduction. My name is Ken Fukushi. I'm the professor at the University of Tokyo, as well as a academic director at the United Nations University Institute of Advanced Study of Sustainability. I share my role there. It is very great honor of myself to be invited the International Conference of Sustainability and Resilience of Coastal Environment 2020. That was actually I received this invitation a long time ago. However, under this COVID-19 pandemic, the situation has been slightly changed, and I'm very much congratulate YTS successfully launched this conference.
Sorry, Professor Ken. Could
yes.
you make a full screen of your screen? I think this is flip. So yes.
This is better. Is it better?
Okay, no, it's better. Okay, good. Thank you.
Good. I saw that, I mean, there. Okay, okay, thank you very much. So I will continue my presentation on sustainable water management system for the resilience of the regional economy. This is one conceptual figure in the coastal environment. Coastal environment, there is a lot of activity. We have a lot of big city, mega cities, small city as well. And this city is supported with three big major activity. One is economy, another one is a human quality of life. And this both is supported by the environment, especially in the coastal area. Marine water environment is quite important, not only just providing these seafood, but also providing a hotel business to provide a good quality of life in resident. And of course, a marine water environment cannot provide water resources because of this, the water is saline water. So freshwater environment is also very important in the coastal area. That will be the big input for economy, human quality of life, and environment itself for the freshwater marine environment. So what is water is vital for the all economic sector and human activities. And economy, human, and environment are three pillars of sustainable regional development. Water has two meanings. One is resources, another one is environment. I'd like to explain one of our ongoing project, which is how to accomplish regional development and water management in coastal country. Establish a framework for comprehensive evaluation for role of water in selected cases in studying Asian monsoon region. Develop a tool to investigate the association between water use and economic sectors, as well as the intersectional relationship, direct and indirect water use. Examine future scenario, link with the water and provide a policy option and to achieve sustainable development in cities in Asian countries. Sorry, the character is very small, but finally, we want to have this extension, to the economic, environment, planning, and social well-being analysis is a final product that we want to have. But in the course of study about this, we have to have a massive data supply in the economic sector and water consumption per economic sector. And we have using an input-output table that is economic analysis. And finally, identify with the sector consume more water in test area. Where we did this project is first place is in Bali, next province of the East Java province, where ITS located, and one test area in Nepal, and another one in India, in Visakhapatnam. And we are planning to extend this project to Thailand and Philippines as well. However, today I brought the case of Bali because it is just next to your city, and most probably you may want to visit this place. And I think I don't really need to explain to everybody because you know better than I. So this is Bali, Indonesia, and it is very famous for the beautiful big coastal beach, as well as a historical monument that in the mountainside. And this is a selected industrial sector in Bali, Bali province as well. And I sorted from the small one to the big one. I selected only 58 subsectors. Of course, I can study all the sector. However, in order to make analysis simpler, we have focused 6 key sectors, which occupy around 77% of the total economic share. That is accommodation and food services. This is mainly tourism. Second is agriculture, forestry, and fishery. Third is transportation and warehousing. Fourth is constructing. Fifth, large retail trade, car, motors, and repair. Sixth one is the processing industry. So these all industry will consume water, but at the same time, it produce wastewater. Last 5 years, Bali, province of Bali has changed its land use tremendously. If you first time I visited Bali, it was I remember like 20 years ago, maybe no more than that, 25 years ago. And I occasionally once a year, at least once a year, I visited Bali. And in the change especially in the south area is tremendous. We have of course Kuta area, Sanur area, and Baden here, and of course there's some development in northern part. I heard there's a new airport will be launched, or it's going to be launched in the north part of Bali. However, majority of the activity is kind of accumulated in this Denpasar area. That is mainly for tourism and some industry. And as a matter of fact, you can see forest is slightly growing. This is a reason of this is urbanization. People left this forest, the rural area, and accumulate to the city. And this abundant area became green. So this is actually not this phenomena. It's not only in Bali province, but it's globally. Last 10 years, green area is increasing because of the urbanization. So this is a risk challenges. Population growth in the province of Bali is increasing. A number of the visitors, foreign visitors to Indonesia, entire country, and Bali is keep increasing exponentially here. And 32% of the foreign visitors go to Bali. Yeah, of course, I have no question about it. I try to visit Bali, even though I have a business in the Jakarta. A bit far, but good things is that there was a direct flight from Bali to Japan, so I can make some little bit long way, but I usually go to Bali, or of course sometimes I go Surabaya and then go to Bali. Rapid urbanization, this is number of hotel is also exponentially growing according to year in the Bali. Water flow, various sector or subsector of industry utilize water. For example, paddy. It uses direct water without having a paddy. The water, rice never grow. And hotel, restaurant uses water directly. They use for the toilet. They use for drinking utility water, sometimes drinking water. And food industry, in order to process it, it uses water. However, this hotel also going to use rice. In the hotel restaurant they serve rice, and then indirectly, this hotel is using additional water through utilizing paddy rice. And this rice is going to be the food industry for processing. For example, make a rice noodle or rice paper or rice cake, or other food their processed product. And then food industry not only just use water directly, but also using the water indirectly. The concept of virtual water is quite similar to this. And this is a little bit more quantitative analysis of this entire water use the measure in the paddy growing. However, also livestock and poultry, food and beverages, food crops, Western hotel and non-food crops also is going to use direct use and indirect use with statistics as well as a questionnaire survey with the help of the Udana University, Dr. Sudarma. We have investigated these results. Sorry, I don't go very detailed, but by having this kind of economic analysis, we can estimate the changes of each sector. If we change, I mean, there are some sector as a scenario, so other sector automatically changes. So the estimate not only just a direct effect, also we can estimate the ripple effect of the economy. I will change the talk to the water quality. Water quality globally, from the viewpoint of water use, agriculture is a majority of use of the water globally. In the case of Bali, there are several rivers, but I pick up one river in flowing to around the Denpasar area. Of course, upstream water having a low concentration pollutant, and downstream we have observed higher quality and higher level of the pollutant, which is low quality of water, because of the urban area or residential area or industrial area emit the pollutant, which is measured by BOD, biochemical oxygen demand, and nitrate concentration. And then it gives a pollution to the downstream. So, in principle, the downstream water is polluted. Who pollute this? Various industry and household as well. For example, hotel and restaurant. Input is food, lives, this is animal health, transportation, textile. A lot of sector giving an input, and then this, as a result, the BOD is going to be discharged to the environment. Of course, there is some treatment here, but in the province of Bali does not have a much of the public water treatment system. So hotel itself has the private wastewater treatment process, and then finally it discharged to the water body. Sometimes it goes to the ocean, the river. Sometimes it goes to the coastal area directly. This is where this pollutant comes from. Biochemical oxygen demand, which is a carbon, majority come from livestock. Second is domestic. From the viewpoint of nutrient, total nitrogen, total phosphorus, both livestock is a major pollution source of the nutrient, as well as the BOD. So we quantitatively identify the pollutant from the viewpoint of BOD for accommodation and food services, which is tourism, for rice, livestock, food and beverages, textile, and wood industry. And as you see, livestock has a major contribution to the BOD here. And how this situation is going to be problematic in the future. We did a little bit projection of the population visitor number till 2035, and this is a pollution load according to the population visitor numbers. And it will be higher, like 20% higher load of the biochemical oxygen demand load in that year of 2035. From the viewpoint of the economy, this is a very good thing because it has a prosperity of the province of Bali. However, the more people come, the more pollution will be discharged into the environment. And we have a several scenario for this scenario, improving water environment. Let's say, problems this problem statement is currently wastewater treatment practice in a limited extent, 1% domestic wastewater. However, industry, they have their own treatment process, most of them, big one especially. For example, hotel, luxury hotel, they have their own treatment system. I'm not quite sure if it's functioning or not, but they usually have. And problem statement is declining assessment in the cultural value of Bali will decrease and attractiveness. If the water is getting polluted, then it will be, it's kind of lose attractiveness. If you have a very greasy coastal area beach, then these all luxury beach hotel or non-luxury beach hotel or walking around the beach does not have much of the attractiveness. Well-being of local residents is also very important in addition to the well-being of tourists. What is a possible solution? In a very simple way, the application with advanced wastewater treatment system. But how much do I need to spend this? And how much benefit do we get? Avoid discharging untreated wastewater into coastal water body and improve the coastal water environment. Overcome water shortage and promote the sustainable economic growth. So we did an analysis in order to compare what the gain and what is the loss. Loss is the cost. And we did a quantitative analysis for this. I made it a very simple way of the expression. The cost is a total investment and operation and maintenance cost for the wastewater treatment process, as well as the waste collection system. And benefit is ensure the growth of the tourism industry as well, as usual. And environmental cost. This is a cost of the environment. There's a way to calculate how much value of this beautiful coastal environment has. And of course, with a good environment, we have a less problem of public health, and we have a less problem of the economic growth ensured. I mean, good environment itself attract business, not only tourism. Economical incentive as well as other incentives. So, of course, I understand that, this total cost is direct. This is cash cost. And, benefit is not only cash cost. These are also, kind of perceptual benefit is also included. So, there, some economists may say, don't mix up with their cash value and non-cash value. But at this point, by understanding that problem, I'm comparing to this benefit and cost. And this is a last slide. Sustainable water environment management is vital for healthy economy and development of the region. This is very important to tell for the coastal environment. And polluter pay policy, that is a very classical policy. If you pollute it, you have to pay. But at this point, a free rider also need to pay. For example, livestock industries, they have to pay the cost for the treatment of the wastewater. Yes, everybody agree with this. But at the same time, hotel business, restaurant business in the coastal area should also share the cost of the good environment. Good environment is not free. So somebody have to share this. Decent environment quality itself has a high value, and this high value should not be taken by free riders. We have to, all stakeholders should share the profit and share the responsibility. In the very old time, we just enjoy good environment, but there is always cost. I mean, the livestock industry, of course, is the one who is polluting. However, we need livestock. We need we need meat on the dish. Whenever we can be vegetarian, but unless we gave up to be vegetarian, we need that is a must, very important industry that all citizens want to have in that region. So everybody has to understand that situation. Holistic and strategic approach is necessary for the innovation and the sustainable coastal zone management. And of course, who is going to distribute it? Who take money from for example, like tourism industry, and who should provide some help to the livestock industry. I think government is the one who should take a read of this kind of redistribution of the cost and proper for the proper management of the environment, coastal environment. And I would like to end my presentation by showing the beautiful beach in Bali. And I'd like to thank Ministry of the Environment Japan, who is sponsoring this entire project. And of course, thank to all Indonesian people who helped this activity. And you will have follow-up information through website, which will be launched early next year, including the result of Bali. Thank you very much.
Thank you very much, Professor Ken Fukushi. We will collect all question in the end of the three keynote speaker. Then we would like to invite our second keynote speaker is Professor Iketut Arya Priya Utama. His lecturer at the Department of Naval Architecture since 1992, got PhD in the University of Southampton in hydrodynamics based on the experimental and computational fluid dynamics, and also got fellow in RINA 2006, professional engineer from UK Engineering Council since 2006, professor of ship hydrodynamics 2007, the first scientist from Indonesia to receive Distinction Medal Award from Outstanding Paper in 2015, fellow of Indonesian Academic, the youngest when elected. That was very nice and wonderful. Vice President RINA Regional Asia Sen 2019, and Secretary of the Indonesian Academy of Engineering since 2020. And Professor Iketut Arya Priya Utama actually also my head of Research Center for Marine Technology and Earth Science. So, Professor Iketut Arya Priya Utama, you will share your presentation or I will share? Professor Ketut?
Okay, thank you. I'll share my presentation, Mr. Chairman.
Okay, thanks very much. I will stop share and time is yours.
Okay. Oh, sorry, what happened with the presentation?
There is some.
Okay.
Okay, good.
No, I think it's okay now.
Okay,
can you see my presentation?
Yes, very nice. Okay, good. Please go ahead. Could you make full screen, Professor Ketut?
Yes, Mr. Chairman.
Okay,
thank you very much. Good morning, everybody, participant to the SRCM 2020 conference. Okay, let me start my presentation. Myself, Ketut Arya Priya Utama, from Department of Naval Architecture, and at present, actually, I'm a head of Research Center of Marine Earth Science and Technology, as mentioned by Dr. Muhammad Nur Cahyadi. Today, I would like to talk about development of green marine transportation. As you can see in this picture, actually, the right one is the present boat. It is a trimaran, but powered by diesel engine together with the use of fossil fuel, and
Professor Ketut, I cannot hear you. There is some problem with connection. Okay, Professor Ketut, there is any problem with connection in your?
Can you hear me, Dr. Chadi? Now?
Yeah, now it's okay. Yeah, now it's okay.
Okay, sorry, but I think there's a problem with my system. Okay, I come back here. Sorry, everybody. Development of green marine transportation. So you can compare these two vessels. The present one on the right one and the left one, actually, what will be developed in the future by naval architect and engineering people. So with this. Okay, here's my outline presentation. Would like to start with the introduction and background of the work, and followed by the quantification of the environmental impact of ship propulsion, ship powering, and then what we can do actually in power saving during designing a ship. And then during the operation, we could also do the power saving. And then followed by auxiliary propulsion devices, and then the economic and environmental issues, and the latest design procedures in accordance with the environmental consideration, and then ended with the conclusion. Okay, should we start with the introduction? As all the shipping company and our shipping people know that the design of merchant ships has always had to be centered of economic viability. So merchant ships actually is the most successful carrier actually, okay, to bring cargoes, people around islands, around countries, much cheaper than if we use aeroplane. The International Maritime Organization, IMO, based in London in 2012, highlighted the urgent need to reduce, in particular, CO2 emissions, as already global shipping accounts for 3 to 4% of the anthropomorphic emissions, and this could increase actually if not taken into consideration or even not controlled. Although this concept is not new actually, and several reports actually noted that it has reached up to 5% in 2 years ago. Today maybe, but the COVID situation is reported to cut to some extent, and we hope that we can cut despite we have to handle the COVID-19. Despite progressive research and development of future ships with very less or even zero emission actually now being developed extensively around the world, including by some institution or university in Indonesia, the use of diesel engine and fossil fuel actually still be available till in the next, say, 20 to 30 years. As you can see actually in roads, say in a big city like even Tokyo, Jakarta, or Surabaya, when electric cars actually now being developed and introduced, new gasoline car actually is still sold in the market, and new coming, even more and more actually. Okay, here I would like to show you some of the idea by naval architects and marine engineers actually, what kind of future vessel with very small, even less, zero emission. So this one actually, the cargo ships powered by a solar panel. So a very brilliant idea actually. The deck actually fully occupied with solar cell and solar sail, actually, even including the navigation area actually. And this actually could be used actually to power ships without using a diesel engine at all. And next, this bulk carrier actually powered by wind. Actually, this wind actually controllable, so can manage the position of the sail actually in order to take the benefit of wind coming to push the boat or the big boat. And this is the idea actually to power container vessel by ammoniac, okay, which is very powerful. And there's even more sophisticated. Okay, so this container vessel actually is autonomous. Okay, the power actually drive through electromagnetic wave and guided by satellite. Okay, this is still under consideration by naval architect, electrical engineer, and even marine engineer, and many people consider in the development of autonomous vessel for the future. And yes, the boat actually powered by hydrogen, also developed progressively in the world. Okay, next I would like to talk about the quantification of environmental impact of ship propulsion. To monitor and quantify CO2 emission, the International Maritime Organization, again, I'm based in London, has developed an index called Energy Efficiency Design Index, EEDI. Actually, can be calculated from the emission of CO2 divided by the transport work. In detail, actually, power times specific fuel consumption times the CO2 conversion divided by the capacity of ships, either in deadweight or gross tonnage, times the speed. Why CO2? Yeah, because CO2 is actually the main actually to responsible to increase the atmospheric temperature. Although there are other particulate matter actually like SO2, NOx, and so on. But the most dangerous one actually the CO2. We have to maintain and manage that. Okay, next is about the powering concept. You can see is in this sketch actually, it's a boat actually having a hull resistance, and to make it move actually, we need the main engine, of course, filling with fuel, and then when the engine work and the energy transmitted through the shaft, and then arrive at the propeller, and then by understanding the what we call the momentum energy, and then there's a thrust actually produce, and then to push this boat to give us the certain design speed. The problem, because the fuel actually comes from the fossil fuel, which produce enormous emission, and this is the toxic actually. That's the problem for us. That's actually the main discussion today. Actually, I would like to talk on how we can maintain and even reduce this emission. Okay, this table will actually show us some of the big boat from tanker, bulk carrier, container, and catamaran ferry. Okay, with the length even up to 300 meters, but for the catamaran ferry about 80 meters, and most of the resistance actually for the big vessel actually attributed to skin friction. Okay, the way actually to anticipate the effect of hull resistance because of the density of seawater, and this costs a lot of energy, and the energy because come from the fossil fuel, we can understand the effect to our atmosphere. And on the right column, this is the drag component actually from this kind of boat. It is small enough, but need to consider, especially when the boat actually run in heavy weather or heavy seas. There are many ways actually people, engineer, naval architects can do actually to reduce the power in a feasible and practical manner. One, by reduce vessel resistance, like make a better design, understand the surface finish. When we put the appendages, try to find the low drag design, and even with the superstructure, also with the low drag design. Marine engineer people can work with improving efficiency of propulsor, and then optimize the hull and propeller and rudder interaction. Okay, For example, like choice of design parameter and also finish in a surface condition, minimize thrust deduction, or even like a recovery of rotational energy. And later about how we can optimize strategy for operation. Okay, we can actually manage the speed like applying slow stemming. Okay, reduce the speed in order actually to fit with the schedule from exit port to the entry port, operating the boat under trim condition, or understanding the weather situation, and what we can do with manage the condition of hull and propeller. So next, I would like to talk point 1 and 4. Okay, the point 2 and 3 actually mainly the maximum of people from marine engineering. So because I'm a naval architect, I consider more on how to reduce the vessel distance from the design and how to optimize the strategy for operation. Okay, what we can do actually to save power during design. There are some idea actually we can do. One, when we talk about hull form, actually, we can consider with what a naval architect understand about ratio actually, L upon volume displacement ratio. The block coefficient is the breadth to the raft, and this the longitudinal center buoyancy. Okay, and local details such as use of this sharp or V, or this the blunt U-shape section forward and aft of the ship, and this will have actually an EVEX to reduce the resistance, and also the use of bulbous bow actually, which is found to be effective at higher speed. Later, the saving can be done by optimizing hull form depending on datum hull of our starting point. Okay, the indications are that further optimization studies can derive overall, and some work report that it could reduce or cut about 5% from this hull form. And when we talk about hull surface finish, as I mentioned, actually the frictional resistance actually takes about 70% of total hull resistance for tankers, bulk carriers, and container ships. Okay, this is the major actually vessel actually to support our economic, not just in Indonesia but around the world. Okay, and any reduction in this component can have significant benefits, of course. Okay, and hull surface finish is fundamental actually to the levels of hull scale friction resistance. Later, significant increases in resistance due to roughness and later what we call falling or marine falling can occur in surface. Okay, when a ship actually stay in seawater, say about 2 or 3 weeks, and then marine falling come and cause the surface become rougher. The frequency of docking to clean the hull has normally been assessed on economic grounds, and emphasis might change to reduction in power, actually driven by reduction in CO2 emission. Okay, we need to consider that rather than just for the economic purposes. Okay, we'd like to know about what happened, the ship drag, the roughness, or the bifouling, or the fuel consumption. This paper made by myself and Dr. Bagus Nugroho, a lecturer in Melbourne University, appeared in Journal of Ocean Technology in 2018. Okay, next we talk about appendages. Appendages such as bilge keels, shaft breakers, and rudder actually require careful design. If not, and it cause big resistance and of course large use of energy. Okay, rudders should be considered as part of the propeller rudder combination in respect to thrust reduction and propulsive efficiency changes. Total appendage drag is typically about 5% of total resistance for single screw ships, and could be 15% for twin screw ships. So we need to consider that. Don't make it more, because if it more, and then more resistance and more energy to use. Next, air drag. Air drag of the above water hull and superstructure is generally a relatively small proportion of the total resistance for tankers and bulk carriers or it can be significant for container ships and fast ferries. Okay, we can see the proportion of the superstructure of those kind of vessels. On the superstructure drag of large fast ferries, okay, there's indication of reduction in air drag, obviously. Okay, this work actually reported by Mullen and Barbie, actually, and the decrease could be about 38%, which is very interesting. Okay, we move on now. What we can do when we operate the vessel in the sea in order to save the power. Speed. For most displacement ships, propulsive power varies approximately as a speed cube. Okay, any reduction in speed can therefore offer significant reduction in power and emission of greenhouse gas. On economic basis, the reduction in speed leads to a saving in fuel, but a loss of earning, and there's a fine balance, okay, between them to have the optimum economic speed. Okay, we need to consider that, because if we just focus on the speed reduction, actually to minimize the emission, and then there's a problem with the income of the owner. Okay, that's another problem. Trim on hull resistance. Okay, the effect of trim on hull resistance have been investigated by many researchers, such as using data actually made from this is series actually from England, British Research Association, BSRA. Okay, it is claimed that such packets actually can lead to typical overall savings of up to 5%. So we can see here in this graph, at higher speed actually, when the ship actually operated in trim condition. Trim mean actually the draft is not similar. When similar, we call it level. So the rear and the front part the same draft, but if not, we call it in a trim condition. So there's a decrease of resistance when the speed increase and operated in a trim condition. Yeah, it is proven. Next, when you talk about weather routing and hull propeller cleaning. Okay, to work effectively, knowledge is required of the performance of a ship in a sea. In particular, speed losses in various forecasted sea conditions. So, okay, you can see yes, the ship actually has to use their energy actually to handle the wave, the severe wave. Okay, if actually the operator can understand and connect regularly with the meteorological office about the sea condition, actually they can avoid the situation. Okay, and then of course save the use of energy. Okay, next about hull propeller cleaning. Hull cleaning is known to decrease overall power, but has usually been carried out on a strictly economic basis. You can see on this picture here actually when a ship actually sent to dock after operating about 1.5 or 2 years, actually full of fouling. Okay, it's very rough, and this caused actually the increase of drag significantly. So this boat, the bottom and all the stuff must be cleaned regularly, actually, to send it back calm like when it is new. Okay, and of course this will reduce the drag and the use of energy. Next, we talk about auxiliary propulsion devices. Okay, whilst number of the devices may be impractical as far as propulsion is concerned, some, such as wind turbines and solar panels, actually may be used to provide supplementary power to the auxiliary generators. Some fishing vessels in Indonesia actually, even though they powered by diesel engine, but they use solar panel actually for electricity. At least actually they can share the energy from diesel engine and what called the fossil fuel, and this will lead to a decrease in overall power, propulsion, and auxiliary electrical generation, and an overall reduction in emitted greenhouse gases. And then what we can consider with the economic and environmental issues between saving the energy, try to improve the design, but in other hand, actually, the shipping company and the crew actually, of course, need money to develop the business, to pay the working hours. Okay, fundamentally, improvements in efficiency of propulsion should lead directly to improvement in the economic return, okay, and a decrease in greenhouse gas emissions. So it is not easy, okay, because when we need to improve the economic return, of course, we need to boost the economy. Sometimes maybe the use of fossil fuel increase, but we have to consider that. Okay, this means there's a double incentive to pursue such efficiency improvement. Okay, next we come to this design procedure. Actually, the left one, this the previous idea, and the right one actually the present idea. Okay, when we build a ship, actually, we need an owner requirement and environmental condition where the ships actually operated, and then later we consider with the feasible technical designs such as principal dimension, the mass and the capacity and the power actually required to push the vessel, and then we make an estimation of building and operating cost and of course revenue to the company. After that, and then we make an economic evaluation of alternative. Then we make a choice and then make a detailed design and construct the vessel in the shipyard. Okay, that's the old idea, and the current idea actually the same path, but here, okay, we need to consider not just economic evaluation, but also the environmental evaluation. So IMO as the body actually responsible for the safety of the ocean in the world actually has taken action actually. Okay, ships operated in international fleets must consider that. That is why the new idea actually not really new, but has been ago actually. People need to consider or combine the economic evaluation and the environmental evaluation, and then we have to weigh this, okay, to compare and contrast the benefit of the two, and then further we go with the choice, the detailed design, and then construct the vessel. Okay, finally, we arrive at the conclusion. Okay, a number of areas have been identified where initial design changes and investment are made and energy-saving devices proposed. Okay, this must be practical, robust, reliable, and safe. And when we talk about design, many sophisticated tools actually, not just the experimental facility, but computational fluid dynamic tools and other method actually has been used very usefully actually to develop suitable hull shapes for particular operational conditions, and at the end we can have ships with better design, with less resistance, and with less use of energy. When we talk about operation, it is found that the most favorable savings of up to 5% by adopting such techniques actually has been proven by many users. In reacting to the pressure to reduce propulsive power, the designer need to investigate every feasibility possibility. Such I mentioned that how we can operate the vessel better. Next, in terms of economic viability, with the increased pressure from the environmental point of view and with the possible future introduction of emission schemes, reduction in power and emission might be achieved. Conflicting demands can therefore exist when attempting to achieve both economic and environmental efficiency. There are two things actually in contradiction, but we have to weigh and then consider that. And when we talk about design procedures, the design process should be adapted to take account of the changing emphasis between economic viability and environmental factors. A multiple criteria approach will be necessary, with weightings between the criteria depending on levels of fuel costs and on what financial incentive might arise in order to persuade ship operators to reduce the emissions. I think that's all I can say, Mr. Chairman. Thank you very much.
Thank you very much, Professor Ketut, for a nice talk. Then the last one, we will invite our keynote speaker, Dr. Aji Pamungkas. This is the profile. Associate Professor Aji Pamungkas now is the head of Research Center for Disaster Mitigation and Climate Change, and former head of Urban and Regional Planning Department of ITS, special research in disaster risk management, coastal planning, development theory, community participation, urban economics, and sustainable development. And also, he has concern in disaster and climate risk management and coastal planning, especially in planning for specific area to regional planning, sharpen his abilities in planning. Now he is a member of Indonesian Planning Expert Association, Indonesian Expert Association for Coastal Management, Surabaya Planning Expert Team, and member of Research Center for Ocean. Dr. Aji Pamungkas, you will share your presentation or I will share for you?
I can share my share
Okay.
screen by myself. Thank you.
Thank you very much. Okay. Now time is yours, Dr. Aji Pamungkas. Please.
Yeah.
Go ahead.
Thank you. Thank you. Let me share my screen. First of all, good morning, everyone. Assalamualaikum warahmatullahi wabarakatuh. Thank you very much for the moderators, Prof. Nur, for very nice introductions. I want to check about my sound. Can you hear my sounds very well?
Yes, very nice. Very good.
Okay. And then about my screen, can you see my screen already?
Yeah.
Yeah. Thank you very much for the clarifications. Okay. This morning I want to discuss about some of my limited experiences and also our research center experiences in making our coastal cities sustainable and resilient. And I want to focus on the institutional approach. What is the resilience? This is part of the coastal community resilience in 2008 when we discussed in the beginning about the resilience concept. It has three meanings, three core ideas. The first one is absorb shock, and then bouncing back and learning adaptations. So when the disaster came to one area, so the community in the area can absorb the shock after the disaster, and then can recover, bouncing back even better than their previous lives, and they can make a learning and adaptation to prepare for the next or others disaster events. That's why it's become our ideas in this presentation. How can we make our cities resilient? And I write my dissertation also about the resiliency concept, and the adaptation is like the key approach to improve our resilience. And my case study will be around in Surabaya, and to someone from outside of Indonesia, Surabaya is in eastern part of Java, is in East Java province, and the location is around here, and this is the Surabaya out of the East Java province. And then from the assessment from 2001 and 2015, we can see there is a rapid changes to build up areas in Surabaya. So the yellow areas are the build up areas. So we can see there is a big changes from 2001 up to 2015. Actually, this is if you expand to the like previous era years, you can see there are more rapid changes from time to time. It means that the city is very active and very promising for development. And then this is the high-rise building. This is the distributions of legalized building from 2012 up to 2015. You can see that there is a big increase also in terms of the high-rise building. I know it is very we are in the hard situations because of this pandemic, and then this legalized building also drop. But in normal situation, we can see there is a big increases in terms of legal high-rise building legalizations. And then this is our proposal actually as the Surabaya Planning Expert Team. How can we push our development in a well manner? It means that we try to classify which area can be the location for the high-rise building. And we can see there is the first area, the red one, is like in the coastal area. So we can see that the Surabaya future development still strengthen the value of coastal cities. So in this red area, we can see the government can legalize the highest building up to 250 meters. And then before we discuss about our actions to make sustainable and resilience, I want to highlight about the importance of resilience in sustainable development. We can see that our sustainable development concept has been expand from time to time. In the beginning, we discussed about sustainable between economic and ecology value. Now we can discuss the sustainable development not only from economic to ecological value, but also social and institutional. And then the last one, we propose that our sustainable development concept should have value of economic, ecology, social, institution, and resilience. It means that we have to prepare for disaster in the normal situation, not in the after disaster event. Because in the after disaster event, it will be chaotic and it is very hard for us to manage everything in a normal way. We have some challenges in Surabaya. For example, that this is the urban fire. We can see there is increasing number from time to time, the fire incident in Surabaya, and we have some opportunity to observe in the special community, in Yamplungan community. At that time, in the beginning, we assess their understanding about the urban fire surrounding the community. And it is very surprised that 60% of the community have only basic understanding. So more than 50%. It means that we are not ready, even though the disaster is already frequently occur in one situations, in one community or one city. And then we also have some opportunities to observe about the UHI impact in Surabaya, especially in the eastern part of Surabaya. I with my students also discuss this one. There is an increasing urban temperatures. You can see the classification is getting higher from 2001 up to 2019. So the maximum at that time is only around 27 or something, but in here dominantly to 35.7 degrees Celsius. It means that there is indication of urban heat island in Surabaya is occur. And then in terms of the flooding, we can see also there is a bit warning in Surabaya as the climate change occur. We can see there is a graphic of here. It means that in the long run, there is an increasing rainfall pattern in around Surabaya. And we have also some opportunity to assess the Kedurus catchment area. Kedurus catchment area is in between Surabaya and Gresik municipality. And at the time, we can see there is a predicted flood that happened in subcatchment number 8, 15, and 24. And then we also have currently assessment on the Surabaya potential earthquake. We have collaboration with the British government to assess about the Surabaya potential earthquake. And this is one of the preliminary output following the announcement from the Earthquake National Center of Indonesia in 2017. At that time, the National Earthquake Center released 280 something of fault line in in Indonesia, and 2 of them is in Surabaya. Now it's like we observe, we probe more in details about Surabaya. So at the preliminary results mentions that in Surabaya the potential earthquake is around 0.55 up to 0.51 for PGA. And then we have also some opportunity to assess about the institutional key performance of Surabaya. We can see here in 2018, we assess Surabaya's institutional aspect in terms of responding to disaster. For example, in here, if, to general disaster, for example, that most of the Surabaya government and non-government institution has already know about the disaster, for example, that flooding or urban fire. They have some, most likely in a good levels in terms of the performance, resiliency performance. But if we inspect for the potential earthquake, we can see there is a low level of performance of Surabaya for resiliency. If we compare to some Asia Pacific cities, we can see that Surabaya, in terms of the potential in responding to potential earthquake, is also very low compared to other city in Asia Pacific. We have some opportunity to compare because we do in the same methodology with other cities from various research at that time. And then how can we start our building institutional resilience? This is part of the actions of PSKBPI. PSKBPI is the former of our research center, currently named PSKBPI, and this is a public campaign in the Curfew Day, and then during pandemic we also have a public campaign during the Zoom. So this is Serawung. It's like a discussion online that we held, not really monthly, but it's like we do it some frequently. Now it's up to the 6 editions. And then we also have special focus group. We have with the government, and some of them with the academics, some of them with the NGOs, try to highlight the risks in the city. Especially this one is about the earthquake, as the potential earthquake is like the new hazard for Surabaya. And then we try also to improve our spatial plan. So this is a kind of proposal about how can we make our spatial planning. What is the process to integrate our spatial planning with disaster risk management. So we have to collaborate not only information, data, and analysis, but also the bodies, the actors of certain risk types from the beginning up to the end of the spatial planning process. And we also make some proposal to the government about our spatial plan. What is the key substance of modification for our spatial plan? We call it RDTR or RTRW, regional plan, and RDTR is like the TEL plan, because those plans are being referred for our government development actions or for community to get the building permits. So is this a kind of illustration? We can see that there is a cities that grows to everywhere, including approaching to the fault line. So this is a kind of the thing that we want to avoid it, try to prevent these build up areas conversions approaching to the hazard. So in the spatial plan, in the future spatial plan, we hope that this kind of avoiding risk become the key concerns of our plan. And then we have also opportunities to evaluate effectiveness of government plan. This is one of our research discussing about the the importance of modeling in evaluating our government plan. We can see that in these current situations, we see there is a flooded area in Skedurus catchment area in Surabaya. But when we project our detailed plan, so we input all the land use plan, and then the government like infrastructure program, we can see there is still ineffective of the government plan. So sub-catchment number 8 and number 15 are still experience flooding. So it means that measuring future development impacts should be important before the plan is legalized. And then we also have a proposal. We also have proposal to the government to highlight about the importance of building regulation modification. So after we modify our spatial plan, we also have to make an alignment for our building regulations, because with these regulations, the government will legalize the building uh, and approve their constructions. So in this case, for earthquake, we propose that the building in regulation, especially the shape of the building, should be regulated or at least recommended. For example, that we have to make our building into a symmetric, simple, and regular shape to increase the resiliency to earthquake, to potential earthquake. And we also have to propose our regulation to modify and add some of the regulation, including the emergency infrastructure, a backup for emergency infrastructure. In the case of disaster, I think disaster become uh, everyone issues, everyone responsibilities, not only government responsibilities. That's why we have to design our cities that our individual parcel lands have their own emergency backup, emergency infrastructures. This is a proposal for complex building, not for the simple building. The complex building, like the high-rise building, usually they have their own emergency infrastructures, but we need to increase the capacity of the emergency infrastructure. So the emergency infrastructures will not only be used by their own building, but also can be used by others, other surroundings neighbors who doesn't have the emergency infrastructures. We know that the complex building have the higher capacity in terms of the money and so on compared to the surroundings area. So the emergency infrastructure should be like recommended in legalizing the building, especially for example that emergency infrastructure to respond on disaster event in terms of the electricity with the minimum 40% from the normal needs, for example. And then about the telecommunication is also important, not only for the people who live in this building, but also for surroundings. So it is important. Will be very helpful if we can advise or recommend or even obligate the high-rise building to complete with the emergency infrastructure for telecommunications, such as walkie-talkie and other portable tools, or maybe like satellite telephones. It's become very important at these current situations, especially during the emergency situation. And then about the clean water and sanitation, we also propose that the high-rise building or the complex building have opportunity or recommended advisable to provide the clean water supply or the water treatment plant to back up their clean water supply at the minimum 40% from their daily needs. And also the waste management plan is also important because the earthquake can damage everything, including the waste management instruments in the area. So waste management plan is also important for us to to provide in a secure place, and then and the complex building, I think, have the opportunity to provide it. Of course, this is not replacing the government responsibility, but adding the government responsibility or capacity at the emergency situations. And this is also the evacuation route and evacuation point. We do that. We believe that this is also important during disasters, not only earthquake, but at this reason, we propose for the potential earthquake, to provide evacuation point in open space, not in a circular space, or not in a route for emergency vehicles. And then the spaces also have to be enough to accommodate all the inhabitants or all the people who live or active in these buildings. And we also propose, since the highest building is more than 24 levels, I think in Surabaya, we need to also modify our building regulations, and with the providing refugee floor, because in Jakarta we already they already established this regulation, but not in Surabaya. And I think that this is also important, especially for the evacuation system. So I think we need to modify this kind of building regulations to improve our resiliency. And then, since institutional aspect is not only about the government and regulation, but also about the system in our community, so we also have opportunity to improve or to learn together with the community, especially in Difabel Community School. At that time, we have outreach program from ITS and in YPAB school. We have the opportunity to assess their understanding on the surrounding risk, and then we can see there is most of them are in a low understanding, has a low understanding. That's why we need like prompt actions to improve this understanding in the future. So we also have opportunity in terms of the urban fire, that to learn together with the community about understanding the risk, and we do the participatory mapping, and this result of participatory mapping of the fire risk event, and then this is a kind of a mapping results, try to highlight about the hazard surrounding of the communities. And then we also try to learn together with the community, and then do some community training with the fire brigade squad from Surabaya, and then they try to increase the value of learning and adaptation. And then we also need to improve their system, the community system, especially for the evacuation route. Like this one is built, is like designed for the Difabel school, and this one is like we know about the resources, current resources that we can be used during the emergency situations. So there are some area still has the fire hydrants, but others, most of them in kampung, they don't have the fire hydrants, but they have some like water storage in their houses. That's why we can use for the emergency infrastructure. They have like loudspeaker in the mosque. They can be used for warnings during the disaster. So this kind of resources surrounding of the community can be used with the good command center, good management, emergency management. And then last, we also have an opportunity to review about our coordinations units in emergency responses. This is from the regulations, and then we modify some of them with the coordinations to not only our field posts for this disaster emergency response, but also for the shelters and also the individual household. So this is important also to integrate not only from the top level, but also from bottom up level. So that's all, I think, my proposal in this seminar. We do hope that we can discuss about some actions that we think that it is important to improve or to make our coastal city sustainable and resilient. That's all my presentation. Thank you very much for your attention.
Thank you very much, Dr. Adi Pamungkas, for very nice presentation. Then we will discuss just about 30 minutes still have, and I will share there is some question for Professor Ken and Professor Ketut. The first, okay, I will ask to Professor Ken first. How about this is from Mr. Edison Itera. Itera is from Sumatra, Professor Ken. If you know Sumatra Island, you ever go to there? Lampung, very west of our island. How about according to analysis, how is the relationship between water pollution effect to paddy production? And then how about mangrove? And also Professor Ketut, I think has many experience in mangrove, so please answer this also for Professor Ketut. And the second question is from Bu Ismurini, University Brawijaya. She asked, would you please inform us more detail on how water consumption is applied in the case study regarding green blue water footprint? And she want to understand how to define the free rider since she want to agree with your idea how to pay for it. And there is also question from Pak Aji. How effective is the current aquifer recharge in Surabaya according to one of your action plan, and how can we improve it? Okay, the time is for Professor Ken. Could
Yes.
you answer? I will stop share. Maybe you want to share something.
Certainly. Thank you very much for your quite interesting question. In principle, I mean, water pollution itself does not affect much for the rice production. The reason is pollution happening downstream. It's not in upstream. And usually the rice production is not really downstream of the water quality. However, if there is a water pollution in the coastal area, this activity, accommodation and food services, will be down. And then eventually, this rice production, there will not much need of rice production. So the water pollution in downstream is going to be affected for the tourism industry, and eventually it's affected the rice production as well. So it's not really directly, scientifically, it does not have much of an effect. However, economically, it will have effect eventually. Thank you very much.
Okay, Professor Ken, this still one question from Bu Ismarini. I think there is still two questions left.
Is that the mangrove things? Is it for me or it's for?
This is for Prof. Ketut. This one, the water consumption.
The second one.
Water consumption and blue water footprint. I think And also,
Would you please inform us some more detail on how
yes.
water consumption apply to the case study? Because the group water footprint, I really want to understand how the water definite free rider, since I agree with the idea that yeah, this water consumption itself is a kind of in my analysis is a direct use and indirect use is kind of mixed, and you know, indirect water is sometimes it is not really consumed in this area. We did analysis within the province, in the Bari province, but Bari province is economically it's not closed. Some material is coming from outside of the province. So the entire water system in analysis is not only in the here. It happened in Bali only. So, you know, I mean, the free rider or responsibility in the principle have to reflect the pricing of the good. You know, for example, like a water tax or something, you know, that would be going to give you a more kind of green, you know, management of the green water, I mean, the issue. And blue water, of course, you know, that is for more kind of environment, you know, related. So we can, if it is quite important to make entire, was my voice was activated? Is my
Yes,
voice?
yes, okay, yes, it's good.
Okay. Then you know it is also important to have a platform that can compare blue and green water at the same standard. I think in my model, I think we can compare these two different, you know, I mean the type of water in the same standard. Thank you.
Okay, this one raised hand, Pak Iko Siswoyo from UII. From the photo I know very well, this is Pak Iko. Maybe you cannot see because I have masker now. I think we are very close friend in Hokkaido. Yes.
Good.
Okay, Professor Pak Eko, you will ask Professor Ken, so please.
Okay, thank you so much, Cak Nur. Even it's been a long time to not to see you, maybe since our graduation from Hokkaido University. Okay, my question is for Fukushi Sensei. So it is Omoshiroi Hapyo Domo Arigato Gozaimashita. Okay, Sensei. So I have a question regarding the coastal management. So actually my hometown is in Lamongan. It is very close to Surabaya. And then as we know that the coastal pollution is very difficult to be controlled, because even, for example, our region already manage the environmental well, but the pollutant itself can come from the another area. So how we can control, how we can manage our coastal area, especially because it's no boundary, because even we already control very strict, so no pollutant coming from our area, but the pollutant can come from our nether region. So do you have idea?
Yeah, this is very difficult question. In principle, of course, you know, I mean, the implementation of policy is very important. However, implementation policy have to be done with economic incentive and community engagement. And since community engagement beyond the boundary, that would be extremely difficult. However, pollution is not as bad as a global greenhouse gas. Greenhouse gas, if China produce, it will be affected Indonesia. And you have no control to China, for example, you know. But in case of the water pollutant, it is at least it is within the same watershed, water basin. So it is also a very important role of the province, or if it's a boundary of the province and the province in a relationship beyond the municipality. The minimum unit of the administration is what, kelurahan, right? Kelurahan in Indonesia, and then finally goes to the country. But within between that, you know, we have to have a little bit the flexible manner of management of their region. I understand, the Indonesian local governance is quite rigid. I had also had time to talk with province offices when I was participating in the RPJMD development after your new governor assigned. But I think the partnership is very important. But I think it is also very important to provide some economic incentive. If you treat waste, then there will be subsidies. But we have to share the profit as well. It's a little bit more like communism type of the concept. But I think in order to survive, the region, not big city like Jakarta, Surabaya is big enough. However, I think we better to have and share the profit as well as responsibility. I think it is good that you have a very good leader, Surabaya. The leader is quite famous worldwide. So, I think you might have a good chance to show the good case of, with urban development. Thank you. Difficult.
Pak Nur, may I have one question to Professor Ketut, because it is also, I think, very important for my area. So Pak Ketut present very well about the smart ship, but it is looks like for the big ship or the big scale. So what about for the traditional fishermen? Because in my place, when the fishermen they go for to get the fish, and then they have to spend much money for biodiesel, for solar. In Indonesia we call solar, because sometimes the money coming from the catching of the fish, it is much less than the they have to spend for for the biodiesel. So do you have like design for the traditional fishermen, because it is very important, I think, for our people in Indonesia. And also for Pak Aji, so regarding I would like to know about the SLF application in Surabaya, certificate layak fungsi, because in Jogja, actually, I also I work for some company to make the study of the SLF, certificate layak fungsi, the study in order to get to certify that our building is well managed or not regarding the environmental regulation. So what about in Surabaya? Thank you, Pak Nur.
Okay. Thank you very much, Pak Eko. Some years ago, we meet again.
Okay.
After only via Zoom, it's no problem. Okay, Professor Ketut, could you answer the question? But I will share also other question together with question from Pak Eko. Yes. So I will answer question Prof. Ketut together with Pak Eko. Then this is the next question about mangrove and pollution, and how is the effort from the ship producer around the world towards reducing the CO2 emission from ship, or does that depend on the government regulation? So, Professor Ketut, please ask 3 questions. Okay, thank you very much. Time is yours.
Okay, thank you, Mr. Chairman. I'll try to answer one by one. Okay, first from the 2 questions, could you show me again, Pak Nur? Okay, there's a correlation between mangrove and pollution, actually. Actually I described during the presentation. Well, yes, ship emission actually produced by the current system, where most of the vessel actually are powered by diesel engine and fossil fuel actually cause air pollution and water pollution. And what is the correlation with the mangrove actually? I think there's no direct correlation, but mangrove can work actually to absorb the pollution to some extent. There's some work done by biological people in the use of mangrove actually to absorb, and of course to absorb CO2 as well. Okay, in terms of that, but in terms of what our field actually, there's some work actually being done at ITS, in several departments and in other institutions about using part of the mangrove actually to put into a coating system. Okay, we mix actually the marine coating and with some part of the mangrove, and then we extract it. Okay, to give some protection actually to avoid to make the biofouling actually afraid to come to a vessel. Okay, when the biofouling not come to a vessel, and then the raft actually become less, and then of course the drag not increase much, and then of course the use of energy is less, and then the pollution is less. Okay, I think that's the correlation between the mangrove with our work. And for the second question, please, Pak Nur, can you show it again to me, please?
Okay.
And other audience can see it. Okay. About how is the effort from ship producer around the world towards reducing CO2 emission? Yes, there is a regulation. So the MO, as the body under United Nations actually release a regulation to reduce the CO2 emission. Okay, because we have to protect our ocean. Okay, the emission actually can increase the air temperature because of the CO2, and also the particulate matter actually can poison biota, fish and other biota in the ocean. Okay, there's a regulation, and a shipping company must obey that. If not, they are not allowed to do international voyage. Not even when come or berthing to a big port, because not follow the IMO regulation. What about in Indonesia? Yeah, there is a regulation, but not that strict as for the ocean going. Okay. So the Indonesian government and the people in shipping industry actually now still work together. Okay, to persuade people actually to obey that, because at the end this is good for us. Okay, for the Indonesian seawater and our environment. Okay, that's the problem with the pollution and the regulation. There's a regulation. And for Pak Eko, okay, thank you very much for your good question. Actually, what I described actually focus on big ships. Yes, you are correct. But the idea actually can be applied to small vessel like fishing vessel, for example. Okay, we can work with the better design, change the design to give us less drag. For example, like safe actually. For example, this one good work actually. I work with my colleague in Diponegoro University when we published one of our work in Journal of Technology in 2015 actually. But most of the work done by my colleague in Undip actually, when they convert actually from monohull to catamaran for the fishing vessel. And they operate better, not just produce less drag, but actually the maneuverability is also good. And the people use that boat actually very happy to operate. Okay, that's one point. And other point, I think we can combine actually the powering with say for the fishing vessel, like a combined sail, the traditional sail, and the diesel engine. When there's a low speed, we can use the sail, anticipating the wind direction. But when we high speed, of course, sail may be not good. We need to use the diesel engine. We can combine it, and we can save the energy, I believe. Okay, hope this help, Pak Eko. Thank you.
Thank you very much for Professor Ketut. And then we would like to ask Dr. Aji. There is some question for you. The first is, so effective is current aquifer recharge in Surabaya according to one of your action plan, and how can we improve it? And there is one question also from Pak Eko about surat layak fungsi, I think SLF. And from Ms. Dida from PUPR, how we can maintain the beach border when the local society already live there, since regulation of spatial planning doesn't exist yet. Thank you very much. Okay,
Yeah.
please.
Yeah, thank you very much, Pak Moderator, Pak Atta, Pak Nur. Yeah, thank you very much for the questions. They are very good questions and hard question to answer. Can I share my screen? Because the first question, I have some works related to that questions. Let me
Okay, please.
share my screen.
Yes.
1 second. Yeah, this one is some of my words that is already written in the one of the journals. It call it green and gray infrastructure approaches in flood reduction. So it is in the same case in Kedurus catchment area. At that time, we tried to make a simulations how effective our instruments to decrease the flood volumes. And we know that in Surabaya, the aquifer is very hard to infiltrate the water. It's very hard to infiltrate in Surabaya, and the groundwater level is also very high. That's why it is important for us to find out what kind of other actions, except the gray infrastructure. Gray infrastructure is the drainage systems. To minimize the flood volume in Surabaya, especially in Kedurus. At that time, we have to we classify into the green infrastructures into two types. The first one is the increasing infiltration rate with the retention pond, detention pond, and vegetated filter strip. And then we also manage the building in Surabaya by regulating their floor average area, or in Indonesia we call it KDB, koefisien dasar bangunan, or and then the GAR, GRA, green average ratio, or the Indonesian term is KDH, koefisien dasar hijau. So we try to manage these regulations in our residential and others built-up areas. So as a result, by applying this green infrastructure with the value of increasing infiltration rate, the effectiveness is only 22.3%. So it is very much not less effective. What I mean is we need more infrastructure to improve our actions in minimizing the flood. And then the second scenario we built about the applying green infrastructures, especially in rain harvestings. This is a kind of rain harvesting. First one is like long storage in the building, and this one we already in place, the regulation already in place, especially for high-rise building, for the complex building, where the buildings have to provide their storage to accommodate the first 2 hours rainfall in Surabaya. So the first 2 hours has to be from all the rainfall in their parcel land should be accommodated in this long storage. It can be underground or anywhere as long as it is in their parcel. And then we also have some best practices from at that time the Litter 2 says in Melbourne about these rain barrels. So in Melbourne they have some actions to rain harvesting accommodated in their water tank in their individual houses. But I don't think so in Indonesia. It's very possible, especially in Surabaya, because the parcel land in size in Surabaya is very small compared to in Melbourne. And some action that already exists in our community, actually in Surabaya, especially in Mauspati, Kampung area, and then some of the cases in Malang. This I got from the Net TV. They installed the water storage actually under the road. So this is a kind of local wisdom that we can adapt we can adapt to provide to make our rain harvesting possible. So this kind of applying green infrastructure we simulate in our case, and the result is it has like 27.7% effectiveness in decreasing the flood volume. I know it is not 100% can decrease or minimize the flood volume in Kedurus area. That's why we still need to combine with our current approach, which is great infrastructures like expanding our rivers, deepening our rivers, and then as long as it is increasing river capacity, we call it as great infrastructures. So if we only do this great infrastructure only, the action will be 100%, but the increases of capacity very much high. It means that it won't be possible to implement it. For example, let's double up our river capacity is like one of the big project in Surabaya. If we try to push this regulation, these actions on the ground, that's why we try to manage to increase to combine the three of them: great infrastructure, especially for infiltrations, and also rain harvesting, and also great infrastructure, so we can manage the flood volume effectively, and then increase the capacity, not in the very large and then expensive project. That's why I believe that by trying solutions, not only current solution like great infrastructure, we think that the flood in Surabaya can be well managed. And then the second questions about the buffer area of our coastline. Yes, there is a regulation about this buffer area, but the regulation has been relaxed by allowing some of the activities, especially for the local society. So as long as it is not permanent, I think the value of our coastline is very high. That's why we also invite the communities to get the benefit of our coastline. That's why the regulation has been relaxed, and then some of the area can be built permanently with the good coastal protections, but other area still managed with the not permanent building, but they have some activities in the buffer area. But the most important thing, if we are approaching the risk, we need to have two actions at least. The first one, that we have to ensure that our building, our response is really equipped very well with the disaster response. If not, we have to avoid this kind of risk area. And then from Pak Eko about the SLF, Sertifikat Layak Fungsi in Surabaya, I think it's already implemented in Surabaya. But we know that the Omnibus Law has already changed everything about the legislation. So we are waiting actually the changes as the impact, as the implication of our Omnibus Law. But previously, the SLF has been implemented following the EMB, the building legislations. So all the regulation has already stated in EMB. But before they activated, because the building activated, they have to get this certification. So the main regulations actually is in EMB, not in SLF. That's why in my proposal, we try to push our EMB regulations in a very avoiding the risk. Try to manage the risk by improving our EMB to improve our building on the ground. So I think the main regulation is in EMB. So SLF is following the EMB. That's the main the key opinion from myself. That's all, maybe Pak Nurjayadi. Thank you very much.
Okay. Thank you much, Pak Haji, for answer. There is still one question. Okay, I would like to invite Bu Warma. Is some question from Bu Warma, please?
Thank you very much, Pak Nur Cahyadi. So I would like to ask to Professor Ken. So Sensei, I would like to ask about the case in Bali Island because this is my hometown. So the first one is about the we have a traditional wisdom that we call it suba for the paddy fields. And how about the sustainability of this local wisdom in this condition? And the second one is about the economic impact to the farmer, especially in this condition. And the third one is about the use of the groundwater. Even in my hometown, also in the south part of Bali, we still use a groundwater, especially for the hotel and tourism activity. And how about these problems based on your research activity in Bali? Thank you.
Thank you very much. About the subak, farming, of course, every country start economy from the farming. That is not much exception about it. However, from the viewpoint of the economic value, this is also true that number of farmers or and economic share of farming is going to be decreased. If you think about it, I mean, the 1 kg of rice, global market price is $1, and that is economically it is a bit difficult to make profit with a small small management of the farmland itself. However, farming, for example, like subak system, from the viewpoint of the water quantity, since I mean Indonesia, our Bali has a 2 meter of precipitation every year. From the viewpoint of that, it is not much problem, even though after climate change, like 1 century after. However, we have to also think about the value of the farmland has, including the landscape, including the educational function, including the resources of tourism, including the biodiversity. We have to find a lot of value of the sustainable agriculture system, which was represented by Subak system. So Subak system has a potential to be the base of sustainable agriculture. However, we have to find other value that everybody want to invest, everybody want to pay in order to maintain the Subak system in the Bali. Third question about groundwater. Yes, groundwater has to be utilized. However, Bali groundwater is a situation in north part or middle part is okay, but in southern part, it's not 100% pure water. It's a kind of saline water, brackish water. So that water is not that much good situation unless it has to be treated. But I want to show one sour experience of the city of Tokyo has. In early 70s, we realized land subsidence because of the unplanned use of groundwater in city. So city of the Tokyo prohibited to use the groundwater. And as you know, many people educated in Japan, if government say no, we just follow. So we didn't use it. But after 50 years, we found out our groundwater is polluted by ammonium. That is leakage from sewer pipeline. Then if the water is contaminated by ammonium, it is impossible to clean it. It takes a long time and take a big cost. The reason is because we didn't use the groundwater for a long time, so we didn't realize the problem. So it is always important to utilize groundwater sustainably in order to maintain the quality of the water. For example, if you have a big money in your bank account and put it in 10 years, after sometimes your wife may use everything, But if you are using that money gradually, then even though your wife or husband use it or your children use it, you realize immediately. So it is always better to use water. But under very strict control. Your second question was, can you repeat it again?
Asking about the, or you already answered about this one, about the economic part, because as you mentioned that a farmer have problems about this. Yeah, we are realizing in Bali about this.
Number of farmers have to be decreased. That for sure. But under COVID-19, I mean, there's some movement of increasing farming because we can do farming over doing the office work. I'm actually connecting from home, now, so I can do farming, afternoon, and in the morning I deliver a keynote speech in the Surabaya. In the afternoon I can do farming. So there's a lot of part-time farming may be implemented, and actually 3 students of mine, Indonesian, Filipino, and Sri Lankan, is working on the urban farming. Actually, one student is working on the Malang city, which has a beautiful urban planning, including the urban farm. Actually, one of the students maybe maybe somewhere here, he's going to make a presentation on that during this conference. So please come and see his talk. His name is Atma Triaja from University of Tokyo.
Yes.
Thank you very much.
Thank you very much.
Professor Ken, there is still one question from Bu Evi.
Yes.
From Institut Teknologi Malang. There is near from Surabaya.
Yeah,
okay,
yeah,
Bu Evi?
Yeah.
Okay, good. Bu Evi, could you ask directly to Professor Ken? Bu Evi? Okay, this I already wrote from you. This from Bu Evi. Bu Evi? Okay, this is the question. Is it possible to treat wastewater, especially domestic wastewater, using complexity mixing in marine?
I don't really get for this question treated wastewater. I'm saying that is there a possibility to treat this salted water, domestic water, using
Oh, okay, Bu Evi already here. Okay, please, Bu Evi, maybe you. Yes.
Hello.
Bu Evi,
Hello.
Yeah, good.
Yeah.
Yes.
Okay. Thank you, Mr. Renal Cahyadi. Hello, Prof.
Yes.
K.
Yes.
Yes, my name is Evi from IGN Malang. It is my big question because I'm wondering about how is it still possible? Is it still possible for us to treat our wastewater, especially domestic water, using hydrodynamic and marine to dilute our water dilution? Because we have many literature about that, and we have many practical about that in out of our country.
Well, I mean, the very straight answer is yes. I mean, it really depending on the size of the, amount of pollutant and amount of the water body that it receives. If you have a small amount of the wastewater, and if you want to use it as a nutrition to the in order to harvest in a primarily producer in the ocean, could be. But the most probably it happened that you have overloading the ocean by the with a strong wastewater that you may have from the urban the city. If you have a very good dispersion, to the ocean, that might be possible. However, in the international convention prohibit to doing this.
Yes.
I mean, the London Convention is not allowed to dump the wastewater to the certain distance of to the sea. So in the past we could do it, but I think if you're Indonesian ratify that treaty, you cannot do it.
Okay.
But in principle, if you stretch pipe into like a 10 kilometer and then disperse it in a good manner, of course, to the ocean, I think, this is my personal opinion, I think it will not have much a problem, depending on the place. Okay. Not in Surabaya, not in Surabaya, but a small city maybe.
Okay. Thank you, Mr. K.
Okay.
Terima kasih, Pak Nur.
Yes. Thank you very much, Bro Evi. And there is some question. Thank you very much, Professor Ken, for answer. Very nice answer. Actually, I have question. If no any other question for Professor Ken, because I already graduate from Japan and 3 years together with Pak Eko in Hokkaido, and we enjoy water and what we drink directly from where in our house we just take water and drink directly. This is from river or from ocean, water from Japan, because oh, I don't know, everywhere we can drink, not necessary from mineral water.
No.
Yeah.
You can drink tap water everywhere in Japan.
Yes. How to process it?
Yeah, there's several water sources. I mean, they're very typical ones, groundwater. We have especially a small water treatment plant. We have around 20,000 water treatment plant utilizing the groundwater. We apply very simple treatment, maybe it's just this mild disinfection. Then we can ready to serve drinking water. But for city, we usually use a river or lake water, surface water as a drinking water source. We apply usually rapid sun filtration, and usually we pass the activated carbon in order to remove the nuisance odor. Very special case, for example, in the case of Okinawa, we use seawater as a source of water, and we apply the membrane filtration, reverse osmosis membrane, seawater desalination, but this is a very small, a very rare case. Usually we use river, lake water, surface water, or groundwater.
Okay, very nice. Maybe we will do like that in future.
Well, but I have a little bit problem. I mean, is it necessary to drink water from the tap? I mean, in order to maintain this, I mean, we have to pay a lot. I mean, we might use, and the water that we need to drink is only 2 liters per day. But we use same water for flushing toilet, gardening. We use everything from a tap, which is drinkable quality water. Maybe this is overqualified, water, and economically might not be so incentive. So I'm not really kind of promoting, everything served from the pipe water supply. Maybe kind of are mediumly treated with water supply, and on the tap we might have a very clean, I mean, like a membrane filtration. Maybe that might be more economically feasible and more wise.
Okay, thank you very much, Professor Ken. We still have 4 minutes. Maybe any other question? If not, I will ask Professor Ketut, because Professor Ketut also originally from Bali. How about green marine transportation in Gilimanuk, from Banyuwangi to Bali, because this is not green anymore. I mean, how to make it clean in transportation, especially in Gilimanuk from Java to Bali, Banyuwangi to Bali. Professor Ketut? I think there is some connection in Professor Ketut.
Yes, can I answer, Pak Nur?
Yeah. It's okay. Good. Yes.
One of the busy actually traffic in street Indonesia, including Ketapang Gilimanuk, ada bisa actually Merak Bakahuni. Yes, I agree with you actually. If we can, what we call, minimize the pollution actually of the ships. Okay, the best way actually, if we can operate like using electric vessel or maybe using a solar panel, as I mentioned. But the research or the production is not like that until today. Okay, it's still ongoing. Okay, the best thing we can do now actually, because we need to consider the environmental cleanliness actually. What we can actually make a combination, Pak Nur. Okay, like what people do now actually combine using the diesel oil and the LNG. Okay, put two type of engine for LNG and then for a combination scheme. Or we can use using sail as well, or some of the electricity we can use solar panel. Perhaps you can do completely the electricity for the light at night actually using a battery and solar panel, and the main engine just used to push the ship. Okay. I think that's the best way we can do at present. But I believe if we can do it, it works well. We can save actually the use of energy, can reduce the pollution as well. It's about, I think, 20 to 25% we can. Yeah. Thank you, Pak Nur.
Okay, thanks very much, Prof. Ikam, Prof. Ketut, and the last. Okay, I think the time is over. I would like share a letter of appreciation from ITS for all keynote speaker today. First is Professor Ken Fukushi as keynote speaker from our Vice Rector. Okay, I will zoom this. Yes, 100%. Oh, slideshow. Okay. Okay. Then also for Professor Ketut Arya Priya Utama. And the last one is for Dr. Aji Pamungkas.
Thank you.
Okay. Thank you very much again for Professor Ken, Professor Ketut, and Dr. Aji for nice presentation. And we will have a next agenda. I would like to give time for moderator to continuing the schedule and agendas. And again, thank you very much for participation, for keynote speakers, and for contributor to this event. Okay, time is for Bu Nisa for moderator.
Thank you.
Thank you very much also for all the keynote speakers, Professor Ken Fukushi, Professor Ketut, and also Dr. Aji Pamungkas. Very insightful presentation and also very engaging discussion. And then after this, we will have a short break. But before that, I would like to explain some of the technical before we have parallelization. So if you can see on the screen, after the short break, we will have parallelization. So we have 3 rooms. I would like to also mention again that make sure that you have the latest version of Zoom app. Otherwise, you cannot access the break room. And also, please make sure that you are signed in to your Zoom account. Otherwise, you cannot join the discussion. Also, for our presenter, please check your room in the email, or you can also check on the screen here. And then please note the number of your the order of the presentation. And for other participants, please join the break room. We have 3 different rooms. The first one is for maritime topic, and then the second we have coastal topic, and then the third we have environment. And then that is for the first session. And then after that, after 12:30, we will have lunch break for an hour. After that, we will continue with the second parallel session. And then we have 4 rooms for this. The first is maritime, the same, and then the second is coastal, and then the third is environment. And if you want to listen to mixed presentation between the topics, you can join the fourth room, which is the mixed topics. So, and also for your information, you are free to move from one room to another room. And for all presenters, in each room, please prepare your presentation beforehand so we could avoid technical problem. And then we'll join again in the main room at 15:30 with the afternoon session from the professor, from another keynote speaker, Professor Thomas Wagner from the Harvard University in the UK, and also from Ibu Liliana Herling from Hasselt University in the Netherlands. Enjoy your time. Thank you very much.
Participants, from your Zoom, you will now see there are several breakout rooms that has been created. You are free to choose which room to join based on your preference of presentation you want to enjoy. As for the presenters, please choose the correct room for your presentation. So you have been assigned to specific rooms for the presentation, so please join that room. As for the other participants, please choose any room that you like to join. For participants who have difficulties in joining the breakout room, please communicate with committee via the chat room. As for the moderators of the breakout rooms, could you join us in the moderators breakout room? For moderators, before you enter the breakout room of the session, could you join us in moderators breakout room? To join the breakout room in your Zoom, you will have breakout room menu. Please click that. And after that, you will see choices of classes available for you. You can just press join in each classes that you want to join. If you want to join class A, so in the right side of the class A, you will have a join button over there. Just click that button and then we will automatically move to that classes. Okay. For you who have difficulties in finding the breakout button, sometimes it is under the, you can see the three dots on the corner of your menu. Click that and then you will have several choices and then you can choose breakout room. Pak Rizwan, could you go to your room in class B? Aduh, kok
Dosen kelas D, padahal kelas D ini. Sorry.
Yeah. So Pak Rizwan Sianturi, could you go to the join room in class B, please? And Professor Anseta, could you hear me? Or other friends still in the main room? Anyone have a difficulty to join? Pak Isa Lembong, you would like to go to which room? I cannot mute myself. How can I go? Pak Rizwan, do you see the break room? Pak Rizwan?
Pak Rizwan jadikan anu saja co-host ya.
Ya.
Jadikan co-host ya.
Oke.
Kita nulis 11:15 ya. Iya. I don't have a. Okay, for you who don't have a breakout room in your menu, it means that you need to update your Zoom first. For you who don't have any Zoom or any breakout menu in your Zoom, then you need to update your Zoom first. Zoom menu is available in the menu bar of the Zoom, or if you don't see it directly, you can click the 3 dots in the corner. Sometimes you have 3 dots in the corner of the menu. After you click that 3 dots, you have several choices of other menu. Then you can click breakout room. Any other friends? Okay, for Miss Asri, sebentar, Asri kita unmute dulu. Let's unmute. Miss Asri, I have asked you to unmute. Yes, you still find difficulties to join the.
Yes.
Okay, wait, because it's supposed to be available in the wait. Okay, I will try to assign you, but I'm not sure if it will work. Wait. Okay, so you are supposed to be in which class, Miss Asri?
In C.
Miss Asri, you are supposed to be in which class?
In C, environmental.
C class. Okay, okay.
Yes.
I will assign you to C class.
Thank you.
Bisa, Bu.
Bentar ini.
Profesor Anceta, Bu Ervin. Kelas E. Bu Erwin, Bu Farida Rahmawati, to class B, to class, sorry, ya kelas B, ya. Kemudian Profesor Anceta, Bu Erwin, enggak di sini beliau ada di Anceta. This is I'm sorry, I forgot. I think it is Professor Anceta is in class A. No, A, marine class. And Pak Muhammad Basir. Muhammad Basir is class C. Muhammad Basir. Yes, class C. C. Yes. Dan oke. Bapak Sunandar Baso. He's already moved. Pak Sunandar Baso sudah pindah. Class A. Already moved, I think. Dida. Anita Rufina. Yes. Ibu Teti Agro. Teti E. Teti E sudah ditransfer. Oke. Nurina Hapsari. To class C. Class C. Yes. Ya. Edison is class C. Edison, can you find it? Class C. C. Murdianto also to class C. Erwin Aldi. Ya. Kelas E. Ready ITS. Pak, tolong ditanya Pak Bangun mau ke kelas mana? Pak Bangun.
Prof Bangun will go to. Do you have any preference to other room, Prof Bangun?
Ready ITS. So for all of you that just attended this conference. So we are right now in the break room. So please, if you can join the break room by yourself, you can choose class A, class B, or class C. Class A is for maritime, and class B is for coastal, and class C for the environment. So if you just join this session, so please, if you have the break room, you can join the break room now. Thank you. For all of the participants, it is still in the main room. So please, if you would like to join the parallel session, you can choose the break room, class A, class B, and class C. So class A is for marine, and class B is for coastal, and class C is for environment. So please goes to the break room, and then you can see different classes A, B, and C based on your interest.
1:30. Okay, and right now maybe we can have lunch together. If you would like to share the lunch in here, I think it's also okay, like me. So maybe also can discuss with other friends in here because it's a
Ya, udah masuk.
fruitful
Halo, Profesor Chang. Halo, Profesor Chang. Professor Chang, could you hear me?
So welcome back to our participant of this conference. I hope you had really interesting discussion during the parallel session. Now we are entering our next session, which is another keynote speaker. We have afternoon session with Professor Thomas Wagner from Heriot-Watt University in the UK. Speaker Miss Liliana Herling from Hasselt University. If I would like to greet first Professor Thomas Wagner and also Ibu Liliana Herling. Hello.
Hello, can you hear me? Good afternoon. This is Tom speaking here.
Yeah, good afternoon, Professor Thomas Wagner. Are you in the UK right now?
Pardon?
Are you in the UK right now? So you are 7 hours behind us,
yes,
right?
Yes, that's correct. Yeah.
Okay, and also Bu Liliana. Good afternoon, Bu Liliana. Oh, it's good morning here in the Netherlands, right?
Yes, selamat siang. Good afternoon. Nice to meet you.
Yeah. Okay, yeah. So for this session will be moderated by Dr. Warma Dewanti. I will read out a bit regarding the biography of Dr. Warma Dewanti. So Dr. Warma Dewanti is an associate professor at the Environmental Engineering Department at ITS. She is the head of Center of Research for Infrastructure and Sustainable Environment in ITS. She has many research collaboration for solid waste, water, and also wastewater treatment, and also research capability management. Recently, she collaborated with IRD France and Hanau Architecture University, working for solid waste management and also mapping of actual related to the recycling process in Vietnam, the West Bank in Indonesia. This part of the scenario on government policy for enhancing solid waste reduction at source. She also has proven track in leading many capacity building programs in local, provincial, and also national levels. She is also certified facilitator and expert who also has competency in know-how on program design, planning, management, participatory monitoring, and also evaluation wastewater and solid waste sector. So for the afternoon session with Professor Thomas Wagner from Heriot-Watt University and also Ms. Liliana Herling from Hasselt University in the Netherlands, and also Dr. Warma Dewanti. The floor is yours.
Okay. So thank you very much, Ibu Nisa. And again, good morning, Professor Thomas and Ibu Lilian.
Morning.
Thank you very much. Yeah,
Hello.
thank you very much. Yeah, good morning and good afternoon because we have a different time. Okay. Thank you very much for coming to this conference. Even as I mentioned previously, we have a different time, might be around 6 to 7 hour difference from Indonesia, but we can meet in this virtual platform. And so for the first keynote speaker, I would like to invite Professor Thomas. But before Professor Thomas deliver the presentations, I would like to share the CV of Professor Thomas. Okay. And Professor Thomas actually have a lot of work together with Professor Iketut Priya Utama from ITS and Professor Thomas Wagner. And right now, he's also the professor at the Research Center and Teams, the Lyle Center and School of Energy, Geoscience, Infrastructure, and Society. And then he has over 2 decades of experience in research and training, and also, of course, his teaching. And then his research is and paleoceanography, geochemistry, sedimentology, hydrology, and aspect of microbiology, biochemical, and also regarding to the global climate modeling and ecosystem science. So without overdue, Professor Thomas, I will share the screen. from your side, Professor Thomas?
Yes, I'll do that. So,
Yeah.
can you see the presentation? You see the
We
presentation?
see it very clearly.
Excellent.
Yeah.
Great. So,
okay.
are we ready to
Sorry,
go?
I'm sorry, could you show with the slideshow? Because it is still in the presentation
Oh, yes.
mode. In the full screen.
Yes. Hang on. What is it you see now at the moment, please?
I can see the presentation about the building zero carbon strategic into coastal planning. Yeah.
Yeah. So you can see the full screen now. Is that correct?
Yes. Yes, that's
Excellent.
correct. You can continue. Yeah.
Okay, so good afternoon, everybody. It's a big pleasure to be with you today. And I'm hearing an echo here of my own voice, so it's a little bit difficult. I'm hearing an echo here of my voice, so I will try to do it. Seen from my background, I'm coming from a slightly different angle. I'm actually a trained geologist and geochemist. So I look at the earth and earth processes from land to ocean. But over the last years, I have been very heavily involved in that really deals about this big question about zero carbon futures and strategies, and how do we tie the different aspects to achieve this big goal together. And my presentation today really aims to take an overview look and give the big picture overview where we actually are at the moment. And let me quickly see if I can move forward, sorry. And it's all about this big challenge. How could we ever imagine that we can pull all of this together? You know, biodiversity, air quality, forests, deforestation, plastic waste in the sea, fisheries, so food supply, new energy. How could we dream of that we could ever pull this together? And we all know, of course, that we are sitting here in the same boat, and we have to tackle this very fundamental question as a global society ultimately, because this is no longer anything which could be addressed at a national scale. So it needs global integrated efforts. And that's what I spend most of my time working on at the moment. So moving forward, what's our starting position? Actually, it's only a good 5 years ago. It's not a long time ago that this very famous Paris Agreement was signed at the end of 2015. And that is also the time when the United Nations SDGs were finally confirmed internationally with the 17 different goals to safeguard and to actually develop sustainable development across the globe. And the big elephant in the room is the ambition which we have. I hope you can see my cursor. On the left top side, basically the Paris Agreement came to the global solution that we really need to stay below 2 degrees C global warming, and better we should aim for 1.5 degrees Celsius as the top maximum warming of the globe in order not to run into real trouble. And we are all aware of that. But then the reality, as you can see it here, this is the very latest record from Mauna Loa from a couple of days ago. You know, we are well above the 410 ppm atmospheric CO2 levels. And we are, you know, the big question, where are we heading here as we are moving into a progressively warmer world? So ambition and reality are a far apart away from each other. However, we know altogether that we need a global response to somehow achieve this 1.5 degrees Celsius aim or ambition. And of course, at the same time that we build new structures which enable countries individually to deal with these impacts, the local impacts on climate change, because in Indonesia, climate change is very different to climate change here in the UK, where I'm sitting. I'm sure you are all aware of that. So this just sets the scene, and the way I would like to structure my talk is highlighted here. So I first would like to give an idea about the dimension of the challenge we are looking at, and then look at pathways and concerns we have in actually achieving this big challenge. And of course, I will focus in the end on one aspect which definitely addresses Southeast Asia as a wider region where important contributions need to be made to actually contribute to this big aim. So here we go. This is from the latest IPCC report, which I'm sure many of you know, with the goal to achieve the 1.5 degree threshold value, which you see on the y-axis here on this graph, and the x-axis is a time series from 1960 with recordings, of course, all the way to today, and then climate projections into the future. Now, we all know that we are on this overall trajectory towards warmer climate. We have probably just reached something like 1 degree Celsius, which we have increased global average temperatures above the background value basically over the last decades. And well, so we know that. So we have already added 1 degree Celsius to average global climate with very high amplitude fluctuations, of course. But the really critical question is, where are we going into the future? And this is where only climate simulations can help us. And if we say we want to somehow meet this 1.5 degrees Celsius, that gives us something like 20 years, maybe 30 years of time to solve that challenge. So this is an extremely short time to global answer to somehow turn around this vicious global trend in terms of climate in which we are. So we all are aware of that we have a narrow time window to actually take action to achieve these big goals. And if we zoom a little bit more into that, so this is the same curve or a similar curve as you've seen before. And you see the time series at the bottom here from 2010 to 2020. So this is where we are. Here we are basically at this turning point. It is now where the decisions really need to be made. Which trajectory are we going? Are we going to go business as usual, the dark blue line? And I think we all agree that this is no option. It cannot be an option for any one of us everywhere in the world. We need to come down from this dark blue business as usual line. And the red line actually gives an indication of what would be needed on a global scale over the next decades to come to somehow achieve something like a 2 degree or even a 1.5 degree global warming. So something absolutely fundamental and radical has to happen across the world to achieve that goal. It's a very, very high ambition. And what is also clear that, and that's indicated in the 3 different colors here, we have to combine different techniques or different aspects basically to come. And first of all, in blue indicated, we have to decrease emissions of greenhouse gases. This is not only CO2, but CO2 is, of course, maybe the most prominent we talk about, but it's also methane and N2O and other climate greenhouse gases, basically. So we really need to do something seriously about this blue area here, and that's indicated down here in the reduce emissions symbol, basically. We have to do something about transport in its very broad sense. This is sort of this orange colored layer underneath here, which is a significant number across the world, of course. So we have to go for decarbonizing transport to rethink economies, and individual transport actually has to happen in the future within countries, between regions and globally, a fundamental challenge. But of course, also, if you think about it, a fundamental opportunity. And finally, in green down here, if we really want to achieve 1.5 degrees Celsius, we need active greenhouse gas removal techniques. We need to employ new techniques which actually actively extract CO2 from the atmosphere and store it away. That is clear now that it's not good enough only to reduce our emission. We need to sequester, we need to basically have a negative greenhouse gas emission profile into the future to somehow meet our major challenge. So it's a whole cocktail of different techniques which we need to move forward altogether. Now, that's the current status of where we are. There are many, many different illustrations I'm sure you have seen and you are aware of. This is just one from a paper, an Earth Systems database, the most recent Earth Systems database from 2018. You always find the references at the bottom of the slides here. And of course, we know the two major reasons why we are pumping so much CO2 in the air. First of all, it's our fossil fuel use, which is still globally the most prominent way of generating energy, and industry. So that is the biggest arrow. As you can see, basically, we're using ultimately geological reservoirs, whether this is coal or gas, and pump that into the atmosphere at an unprecedented scale. And of course, that is directly linked to development of growth across the world. And of course, growth is in principle something positive because it's one mechanism which helps to bring people across the world out of or into better livelihoods ultimately. So growth is nothing negative at all. It's something we really want and need. But at the moment, we have the wrong cocktail to actually deliver that. And the other one is here on the more right-hand side in this cartoon, that's land use. I mean, land use change is the second largest emission origin in terms of CO2. Both of these two major emission components pump enormous amount of carbon into the air every single year, and the average atmospheric growth per year is something like 4.7 gigatons of carbon every single year. We're adding more into the atmosphere. Of course, our nature does us a favor because there are sinks. So forests, for example, as we all know, they store a lot of carbon, they sequester the carbon from the atmosphere, and our big, big friend is the ocean, because the ocean, of course, does a service which is unusual and very important in terms of sequestering CO2 from the atmosphere. So on the right-hand side, you actually see where all this carbon is going. You see a time series again from 1900 to 2020. On the right-hand side, on the top part of the panel, you see the different contributors to the emissions. And the gray one is the fossil fuel and industry. That's by far the biggest one. Not a surprise to us. And below that, actually, we see the three spheres where basically that carbon can go. The ocean takes up more and more and more carbon, creating chemical change in the ocean. Ocean acidification is only one aspect of this problem. The land surface takes up CO2 from the atmosphere. However, the vast majority in this pink color here at the bottom is actually in the atmosphere. So the more we are pumping more up there, proportionately more of that CO2 stays in the atmosphere, cannot be absorbed by either the land or the ocean. And of course, that makes the situation even worse. So we are in a real dilemma. But the big question is, can we solve that problem? Because we are aware of the problem, we can put numbers against the problem. The next question is, can we do something about it? And there is a large number of recent reports which look at this challenge of greenhouse gas removal. Can we really do that? What kind of solutions are there? And as I will show in the next slide, we have a hell of a lot of different tools to hand to address that question. But first of all, as I said earlier, we need to remove greenhouse gases. That's number one. And we can involve different techniques from biology. We can accelerate reactions with rocks. So rock interactions are very, very topical at the moment. And we can engineer chemical processes where microbiology becomes really important in the future. So we have a lot of good ideas out there which we can use, which would reduce greenhouse gas actively from the atmosphere. And the second point, we need to store that carbon away. So the one thing is that we remove it, but then we need to store it over longer time periods. And of course, land-based biomass is a prime site where we can store carbon. Very topical, of course, is deep subsurface geological formations, carbon capture and storage, CCS. It's of course a global technique which is employed now. The ocean is more and more actually in view to become an even more important store of that carbon, or interestingly, the built environment. So the whole way how we are actually running our engineering and our built environment needs to change. Now there are trade-offs, because each of those techniques above, then they require resources, whether this is land, energy, or water. So none of these techniques come for free, not at all. They have resources and they also need space. So that leads into a competition where we need to find a balance. What is actually acceptable to society and to the environment in terms of deploying these different possible greenhouse gas removal techniques? Having said that, some of these techniques are actually really positive because they produce co-benefits ultimately. And that could actually be a very important, not only a side aspect, maybe even the primary reason why we want to use it, because it can, for example, increase the productivity of crop, so food security, or it can actually help to enhance biodiversity. So what kind of techniques do we have at hand today? Each of these symbols stands for a hell of a lot of engineering and pioneering ideas, and we have many, many, many techniques which help to remove greenhouse gas. We can start from the top and actually moving away not only from deforestation globally, but actually to afforestation or reforestation. If we would be able to actually have major projects which would start reforesting global forests, we would make a big contribution. Coastal regions are at the heart of this challenge, of course, with wetlands, peatlands, and coastal habitat restoration. Of course, Indonesia is directly at the hotspot of this kind of an environment here to make major contributions. We can go into the ocean. There are pioneering projects which look at changes in the alkalinity of the ocean or in ocean fertilization. Both of them can actually sequester CO2 from the air and store it away. We can look at the whole question about food supply on land, so agriculture, new techniques, new improved techniques to improve the quality of soils, which of course provide our crops and our food on land. Very important. We can use biochar to further enhance basically the quality of the soils, and by doing that, of course, also sequestering carbon, which is locked away in the biochar, ultimately in the soils. We can move into techniques like enhancing terrestrial weathering, or we can move into more practical things which go into infrastructure. So we can use into mineral carbonization. We can look into new types of concrete, really interesting ideas and concepts to actually build new concrete, which takes up CO2 from the atmosphere and it becomes part of the building material. And of course, building with biomass. So we have a whole portfolio. And in the middle here, these are combinations of all these different techniques. So bioenergy with carbon capture and storage is a very, very highly ranked combination of techniques. So here we are using the subsurface, the deep subsurface, where we are storing away, we are capturing the carbon and we are locking it away in the deep subsurface, or direct air capturing, DAC, with carbon capturing. So it's not like that we don't have a hell of a lot of really good ideas to move forward. And in a matrix, it's the same what I showed to you before. So we have here on the x-axis the greenhouse gas removal methods. So increased biological uptake, natural inorganic reactions, engineering removal. And then on the y, we have the storage location. Where would we actually store that carbon? And you see the different, in this matrix, the different colored regions, those in green. This is basically where the storage is integrated in itself. So if we, for example, have improved land vegetation strategies globally, we will improve the carbon stores and we will lock the carbon away in the living biomass, just to give one example. Or we can actually look into improving soil carbon overall, and of course we would store more carbon in the soils than we currently do. And all those other ones which blue, they basically need a separate storage mechanism, and that separate storage mechanism is either the deep subsurface, CCS, carbon capture and storage, so pumping CO2 from the atmosphere into the deep subsurface and locking it away down there, or alternately moving it into new materials, such as, for example, concrete. It's not only concrete, it can also be biomass. So we have lots of different techniques and pathways which we can use. However, the problem is that all these different techniques are all very early days. So at the moment, most of them, they're in a pilot phase. They are not really up to scale, and there is no full life cycle analysis of all these different techniques, which would enable us to enroll them at a global scale, at industrial scale globally. So that's a real challenge we are currently facing, people who work on these different techniques. And most important, we need to build public acceptance, because we can, as engineers or as scientists, we can think about a lot of good ideas, but we need to have the public with us along to actually build the acceptance we need so that these new techniques are actually supported and wanted by the society and the people. So this is a very recent paper in PNAS, and it looks into the details now of all these different techniques. So we have a really good understanding today about the individual carbon emission profiles of all the different categories, whether this is energy, building, industry, transport, agriculture, and so on. But more important, we have this portfolio of different activities which we could really use now to actually take action and to somehow combat or move towards zero carbon. And you see here different pathways on the lower left-hand side with different arrows. So some of these pathways are basically cyclic pathways, others are open pathways, and those with the red arrows are closed pathways. So this is where we are really over longer time periods locking away carbon, which we are sequestering out of the atmosphere. So it's not like that we don't have great ideas and great pioneering techniques available across the world to address that challenge, but we have to, of course, combine all these different techniques together to somehow meet our zero carbon challenge. So this specific study here in PNAS, published in PNAS, actually takes a look forward and actually looks at the scale of what these different techniques can achieve. And so there are clearly scientifically sound estimates that actually, if we would pull all these different techniques together into one joint concept, that we can indeed meet our global challenge. However, there are, of course, as you can imagine, major barriers to the implementation. And that is, of course, a big challenge which we are currently facing altogether. So I want to emphasize one thing in here, because that's directly relevant to Southeast Asia and, of course, also Indonesia. And that's this concept of natural climate solutions. So there's concepts basically moving which are looking more at what can nature actually do. And that's a really interesting paper published in PNAS in 2017, looking at natural climate solutions, and which is a combination of 20 different actions or activities which would look into the conservation, restoration, and land improved management across different carbon stores, which are part of our ecosystem, if you want to call that. And they come to a really interesting conclusion in this paper, actually, that they say the potential of our natural climate environment is so much higher. It's maybe 30% higher than we have previously estimated. So we have an enormous potential in our natural environment, which we need to harvest and we need to build into our global strategy. And that specific study here came to the conclusion that actually it's a major, potentially a major asset which we need to include into our global strategies forward by using more and more efficiently our natural environmental carbon solutions. And one aspect shown here is basically the question about deforestation or reforestation. You know, we all know that deforestation is a global problem. And here you see a map which actually shows in the different colors the potential which basically reforestation on a global scale can play in tackling the CO2 challenge we are facing. And not a big surprise, whole Southeast Asia comes up with a relatively dark color. So there's an enormous potential in the tropics in general, but also in, of course, Southeast Asia in the wider sense to make a meaningful contribution to this problem or to this challenge. So we should not underestimate the potential nature actually can offer if we include that into our global strategies. So let's have a look at another aspect, which is part of that whole equation. That's biodiversity. Because as we all know, the one thing is our living environment for us humans, and we are more and more under pressure, but equally important, of course, our environment in the broadest sense and biodiversity overall is in a really, really critical situation. We are all aware of this. We are all concerned about that. And there are many, many high-level reports out there which just came out over the last few years. I'm just showing some of them. The Global Biodiversity Outlook is just one of those ones. And biodiversity loss and ecosystem collapse rank as one of the top 5 threats humanity will face in the next 10 years. So it is so fundamentally important with the whole question about climate and where are we going, not to forget about basically the living environment in which we are, and that is biodiversity and ecosystems, and how do we actually tackle that. And the Aichi biodiversity targets, which are basically taken forward by the Convention of Biological Diversity, is the leading global framework to address that question, to somehow identify how we can cope and how can we turn around biodiversity loss at a global scale to somehow become part of this equation of climate futures. So it's a very fundamental, and I'm sure many of you are aware, it's a very fundamental challenge we have, that our biodiversity at a global scale is under threat. And of course, we as humans live from and of course are part of this living planet, and I'm sure we all agree that we really need to take care of that. So there's a different component to this equation, that's biodiversity, a healthy biodiversity for the future, which keeps our planet as it actually is in its all variety. And I'm just giving here a couple of slides to give an idea about the dimension. So in this report, basically socioeconomics come really in here. I mean, we are building our environment through socioeconomic systems, and the big elephant in the room is actually food, land, and ocean use. So that basically contributes 72% with 7 major threats to this whole question about endangered species. So biodiversity in its broadest sense. So we are impacting as humans in a way on our land surface and in the ocean through food supply, through energy supply, and so on, which actually has a very, very decremental impact on the ecosystem in its broadest sense, the living ecosystem. And if you add all the 3 different main players together, so food, land, and ocean use, the big one with 72%, infrastructure and the built environment, 29%, and energy and extractives, so that's basically minerals from the subsurface, including oil and gas, 18%, something like 80% ultimately of our climate change impact is associated to these 3 socioeconomic systems. I'm sure we're all aware of that, but it shows where we need to put the main emphasis in to turn this negative trend, which we currently have in degrading our biodiversity, around to something more positive. So we really need to take action, not only with regards to global warming, but also with regards to a sustainable ecosystem on a global scale where humans are, of course, part of. And in the Global Biodiversity Outlook, this is just one of these summary papers or summary charts, basically. So we are having this problem that we are losing biodiversity across the globe. Doesn't matter whether it's polar or tropical, it's a global problem. It's a really big problem. And we really need an agreement on a global scale to conservation and restoration action. And they have to be really bold and ambitious and far-reaching. And we really need to have a fundamental change in the production in agriculture, trade, and consumption. So we really need to change the way how we currently live on the globe to somehow address this biodiversity challenge which we are having. And of course, as always, the effects are most strongly in those regions where many indigenous and poorer communities live across the world. So they always face these negative impacts the worst. So there is, of course, a responsibility of the Western world, or the world which actually has more resources, to think about that and to come up with a global solution which reduces these negative effects on indigenous communities, local communities, and poorer or vulnerable societies on a global scale. So we have a joint responsibility altogether. Now, as you can see here on the right-hand side in this chart, meeting these challenges has multiple layers. So it's not only about conservation restoration, it's climate change action, as we discussed earlier, reducing global warming. We need to reduce other drivers which impact on biodiversity or biodiversity loss. We have to have a far more sustainable line of production, and we need to change our consumption. Moving forward. Risk and businesses. So we all know we are living in a world where businesses drive decisions. Political decisions are driven by businesses to a very large extent. And here I'm just showing you two reports. One is very, very recent, the one on the top right-hand side. Excuse me, the Global Risk Report from the World Economic Forum. And I can't go into the details here, but you know, we really, our world has changed fundamentally. So 70% or 78% of the people which have been investigated globally basically see economic confrontations as the biggest risk in the future. Climate change is a really big thing which everybody starts thinking about these days more than in the past. And most importantly, on the left-hand side, you know, in the past, we had certain alliances across the world to tackle these big challenges here. But basically, these longer-term structures and alliances don't really work anymore today. So we are in a world which is in transition into a new system of multilateral agreements, which is... Hello?
I'm sorry, Professor Thomas, your PowerPoint presentation is shut down. Could you
Oops.
please again to us?
Okay.
Yeah.
Sorry?
Could you share the PowerPoint presentation, or I can share from here? Yeah.
Can you share what I just have sent to you?
Yeah.
Thank you.
Yeah,
Oh, apologies for that. I didn't know that.
Yeah. So.
Yeah, I just tell you when to move on. Yeah, that's where we are. Perfect.
Okay. And then I will be sure for the...
Yep.
In here,
Superb.
Professor?
Yeah, if you just move one forward, please.
Okay.
Thank you. Excellent. So sorry for this technical challenge. I wasn't aware here on my end. So there is a fundamental challenge about risks and global businesses, which we need to put into our equation. And there's a lot to read and to understand about that. But ultimately, it's ultimately the challenge which you see on the top left side. If we actually want to move forward into a more sustainable world which can grow, with business, of course, being fundamentally important to that, we really have to change gears. We really have to make something fundamentally different to what we are doing at the moment. And we are moving towards so-called tipping points. So points of no return, basically, where nature and climate strikes back. And if you look at the number which you see up there, it's 44 trillion US dollars, which are potentially under threat because of this loss of nature. So the dimension of this problem is so big that nobody of us can grasp that, but it's clear that this is a global problem and we really need to do something about that. We need new solutions which put businesses and environmental concerns and social development into one agenda and not have it separate from each other's, basically. And if you look at the bottom two blue boxes, basically, there are, of course, smart people, economists, which are looking at that. So we basically can actually come up with, we need to invest enormous amounts of funds globally to change this currently toxic development, which we currently have. Actually, we need to change on a global scale how we are operating businesses and manage the risks which we have. So we would have to invest something like 2.7 trillion US dollars per year until 2030. These are absolutely unbelievable numbers of funds which will have to go into that to actually develop a new strategy for technological innovation, which would actually put us onto a different path. But if you put that into equation to the box on the right-hand side, so if we would do that, if we would, as a global community, say we're going to invest this enormous amount of funding on a global scale into strategic new infrastructure, ultimately, we would gain something which is so much bigger in terms of not only in maintaining our environment, our earth, which we all like so much, but of course it creates new business opportunities, which may be worth 3 times more than the initial investment. And of course, it would create jobs across the world. And of course, building new jobs and having job security is a very fundamental, important thing, which we have to have in our equation when we talk about reducing poverty across the world, especially in countries which are still suffering quite high levels of impoverished people. So there is a business case behind that. The business case is enormous and big, but it's not all negative. I think we need to take a look at this in a more long-term and positive view and see where all this may be leading. And it will be a different world to which we currently have today. And if you could please switch to the next slide. Thank you. So this is from this report, which I just mentioned. And what you see here are these 2 colored panels and the different, so from the bottom to the top, this is basically a calendar from 2007 to 2020. And as you can see on the left-hand side is the likelihood of basically impacts or risks. And on the right-hand side is the impact it has. And you can see that we are in a new world. We are, since a couple of years, something probably like 2017, we are in a new world where the color green dominates. And green is the environment. Green has gone to the top level on a global scale in terms of the biggest threat, but also the biggest potential to somehow safeguard our planet and turn it into a positive development. You see in blue, in the years which go up to something like 2015, that is the economy. So economy used to be the really big elephant in the room in the past, both in terms of likelihood of negative impact and in impact itself. This is no longer the biggest challenge. The biggest challenge sits in the environment, and it sits in the geopolitical situation in orange, and on the right-hand side, the society. So failing in urban planning and so on. We are in a new world in that respect to find new solutions, and the environment in its very broadest sense must be part of that solution. That is a game changer, but it's also, of course, an opportunity for us to think about how to actually deliver that. Can you please move forward? Okay. Let's focus on zoom in. So this was global politics or global development. Let's zoom into Southeast Asia and I'm only talking about one specific aspect. Next slide, please. Right, so here we are. Let's look into the tropical coastal regions. And as we all know, of course, the tropics are rich in almost everything we can imagine, but the coastal regions are unique in their tropical mangrove forest systems. The whole tropical regions and parts of the subtropics are covered in the coastal regions by mangrove forests. These are particularly important ecosystems, as many of you will be aware of. But on the other hand, there is a challenge because more and more people and cities are actually in and directly at coastal regions. So they are directly challenging and taking away land which would be needed for healthy mangrove forests, as you can see in the top right picture, as opposed to the top left, which is a relict of something which used to be a mangrove forest in the past. So let's focus on the tropical regions, and here specifically in coastal regions where mangroves are the natural dominant ecosystem. Next slide, please. Thank you. Oops, one up. Right. So there's a very recent paper which I would like to draw your attention to. It's in Global Change Biology. It's a paper which just has come not too long ago. And it's a global assessment of the decline of human-derived mangrove forest. And as we said before, this, or as you of course know, this is a tropical, primarily a tropical, not exclusively, but primarily a tropical ecosystem. And you see a map on top with the different colors in terms of where basically mangrove loss is happening. It's happening across the tropics and subtropics globally. It's a global problem. And as we know, these mangrove forests have some very fundamental ecosystem services they can provide to society and ultimately biodiversity itself. Now, if we look into the different regions, you see in the panels below there, the different regions, and you see that the mix of different reasons for the decline in mangroves is actually different. It's not everywhere the same. It depends on where you are. So the different color coding give you different indications of what's dominant. If we look at Southeast Asia, indicated with the F, you see the color orange is basically dominating. It's clearly dominating, and that's commodities. So Southeast Asia is in that respect globally unique because the decline in mangrove forests in coastal regions in Southeast Asia is to a very large extent ultimately driven by those so-called commodities, and that can be agriculture, and things like that. So the degree of coastal transformation in Southeast Asia to build new agriculture and agriculture facilities is enormous in scale and clearly is unique if you look at these different colored panels which you see at the bottom with regards to the globe. So the pathway which we currently see in Southeast Asia is very, very biased towards reusing the space of the mangrove forest itself to replace it by agriculture and by agriculture. It's about on the order of 62% of the global mangrove loss. And of course, you can imagine that this percentage will be even higher if you look into Southeast Asia itself. So that is a problem, and that's a specific problem in Southeast Asia. So a solution, for example, in the Amazon region in South America, the D, if you look at D, will be significantly different as opposed to, for example, a solution or a cocktail of solutions if we would go into Southeast Asia. So we need to somehow address this question of agriculture, and its negative impact basically on the future of mangrove systems ultimately. However, what we should also not ignore is that there's a hell of a lot globally of very good positive examples at the pioneering stage at the moment, which lead the way to something better. So it's not that we are running blind here. We actually do see positive developments across the world, but they are not yet at the scale needed to turn these negative global assessments, which we see them here, into the opposite. And something new comes in here, as you can see in the lowermost right bullet point, the emergence of natural drivers of loss becoming more and more important. So all of a sudden, natural drivers of loss of mangrove forests kick in. This can be sea level rise, this can be storm intensities, and any other kind of threats to coastal regions in the tropics. Can you please move forward? Okay, now let's zoom into the hotspot, and that's Southeast Asia, as you are aware of. So this is mangrove deforestation in Southeast Asia. So on a global scale, this is the hotspot where this problem is most prominent, and you see in these orange little boxes where the localized hotspots really are. Of course, also Indonesia is part of that equation, as you will be much aware of. So it's a real problem across Southeast Asia. It doesn't matter where you go, it's a global problem. And it's all related to this commodity production as a main driver for mangrove loss. Agriculture is still the dominant factor across Southeast Asia. So building new agriculture factories, ultimately, which feed the global demand for prawns and you name it, including the UK, of course, where I'm currently sitting, is a challenge to the environment, but it's part of the global economic belt, if you want to call that. But we need to do something about that. And I would like to point to you this publication, which I have at the bottom. So there's a relatively new annual review, basically, which I've put the title page on the left top on the bottom left, and that's a really interesting paper I would like to recommend to you for reading, because it's the most comprehensive summary on this kind of challenge which we are facing. Okay, moving forward, please. Now, why are mangroves so important? Mangroves provide, like almost all ecosystems, a value to life. However, what was maybe underestimated in the past, and that is highlighted in this paper here from 2011 in Nature Geosciences, is that mangroves host enormous amount of carbon. So the carbon storage potential of mangrove systems is probably much, much higher on the global scale as we would have expected from in previous studies. So there's a very good reason why we actually focus our emphasis on mangrove and mangrove coastal belts, basically, because they may, if we keep maintaining them and making ensure that we are careful with the future of coastal mangrove systems in tropical regions, we actually may have a natural solution which could help us to address the challenge of global warming. The CO2 reduction potential in mangroves is massive. And as you can see in this panel on the left-hand side, it's basically the soils below the mangroves. They have an enormous large potential to store carbon. So it's not so much the standing biomass itself, which holds carbon, but it's actually below the vegetation. It's the soils, it's the topsoils basically, which have an enormous amount of storage potential for carbon. And that is, of course, something which we need to put into our practical solutions when we think about how can we improve situations, that we also look into the subsurface and into the near subsurface and look at the carbon stocks in the subsurface. And clearly, as you can see in this specific study, the mangroves stand out by far against tropical upland forests, temperate forests, or boreal forests. So here's an opportunity. Here is actually an opportunity to be aware of this service tropical mangroves provide, and actually build strategies around that to combat global warming. If you can please move forward. Okay, so we have lots of aspects, and can we meet actually all these challenges which we have been talking about? And these will be my last few slides, if you just please move forward. Right, many people, as you know, across the world deal with this question, and there is some very, very new recent papers. This one here came out at the end of last year in Nature Sustainability, and it looks at the United Nations SDG agenda and tries to put everything together and having two endpoints. The one is called leaving no one behind, which means basically we have a responsibility for ecosystems and for people across the world, even in countries which are poorer, to take them on board towards a more positive development. And on the bottom, basically, we need to look into the decoupling of growth, whether this is actually economic growth or social growth, population growth, and circularity. We need to come up with new solutions. And you see 6 different bubbles here, which represent 6 different transformations. From the top right, education, gender, inequality, then health, well-being, and the development of demography, to energy decarbonization and sustainable industry, moving over to transformation number 4, which is sustainable food, land, water, and oceans, for moving on to the built environment, sustainable cities and communities, growing mega cities, all these kind of challenges. And finally, and maybe new to some of us, maybe, is actually the digital revolution. I mean, we are moving into a new world where the digital world takes over our previous world, and there are of course threats, but there's of course also big opportunities by turning this digital revolution into sustainable development. And as you can imagine, that is a global wheel we are looking at here, which is very, very difficult to tackle. If you can move, please, forward to the next slide. Thank you. And in that paper, you see basically all the SDGs. So the Sustainable Development Goals on the top, all those 18 different Sustainable Development Goals by the United Nations. And you see the 6 different threads at the bottom. And each of those different threads ultimately feeds into this global network spider web, ultimately in developing a future which is safe and maintains the diversity of life towards a more positive development. And there are, in these different blocks, obviously there are different requirements, and it's in this specific paper they are addressing what these different blocks must basically take care of. So it's meeting standards for new technical feasibility. We need new pioneering techniques which we can roll out on a global scale. We need to resolve the question of trade-offs. That's a really important question, because whatever we do, there will be a trade-off, and a trade-off can be negative. We need to look into the financing of all these global transitions. So this is where basically public and private financing has to come together. We need to look into development of new improved technologies. This has been a key driver of the whole agenda we are talking about. And there are many pioneering industries all across the world. Many of them are very small, who come up with very smart new ideas to make a contribution to this big challenge. We need to look into policy making at a global scale. Coherence in policy will become fundamentally important to deliver this new global goal. And finally, we need to make sure that we take the society with us, because obviously politicians and industry, they can decide a lot of things, but that doesn't mean that the people ultimately are joining in and that we are moving jointly towards one joint goal. So taking the public society on board on this journey is a fundamental requirement towards actually a sustainable future for all of us. Next slide, please. And industry, of course, is always a little bit more excited. That's my last slide here. So there's a paper which came out very recently on the Making Mission Possible. It's the title. It is more coming from the industry. So it is indeed the case that we have ideas how we could jointly, as a global society, move forward, allowing growth to the benefit of the people, but not destroying ecosystems, which cannot be acceptable. It cannot be something which we can accept on our blue planet here. And you see on the lower right-hand side of a timeline, a time trajectory, how we could basically move into a new world where zero emissions are part of the equation and actually keep our global climate in pace, but at the same time allowing positive growth through new technologies. And that leads me to my last slide. Please, thank you. So this is just some concluding remarks from my end, basically. So we are all aware of that we need global coordinated action. If we want to tackle this question, there is no way that individual countries or regions can solve that. We need to join into a joint global strategy to develop a zero carbon future for all of us. We need new technical solutions which we can scale up to a level so that it can be deployed at a global scale. At the moment, we have many cool ideas, but many of them are really in an early day, in a pilot stage. So we need to upscale those techniques. We need to carefully look at the environmental trade-offs. This is a really critical point where at the moment there is still lots of uncertainty, because if we can employ all these technical solutions and reduce our carbon footprint, but that doesn't mean that there are other negative environmental trade-offs somewhere along that supply chain, if you want to call that. So we need to make sure that we have these trade-offs in mind and find an acceptable solution to that. Coastal environments will be key to the future. We know that for many reasons, because more and more people move towards coastal regions. The biggest cities are developing in coastal regions. So this is the hotspot where the pressures will be the strongest in the future. They are already very strong, but they will probably increase in pressure ultimately. And we need these integrated approaches. And we need to somehow try to turn these negative impacts, which we see now, into new development opportunities. And safeguarding tropical mangrove forest as just one aspect is absolutely fundamentally important. Indonesia and of course the southeast of Asia, the whole coastlines are captured by these beautiful environments, and they have a major important role to play, not only in the carbon story, but of course they are also defense systems, natural defense systems against sea level rise, which is of course a co-product of global warming and extreme climate events. So we must make sure that we somehow find a balance in maintaining these global mangrove forests, wherever they are, as a unique ecosystem which provide a unique value, but at the same time move together forwards towards a sustainable development. So with that, I would like to thank you for your attention. I'm of course always, you see my email address down at the bottom, you can always contact me, and I would like to hand back to the conveners of the conference now. Thank you very much.
Thank you very much, Professor Thomas, for a very comprehensive presentation. It's very interesting. And for all of the participants, please hold the question to Professor Thomas, because we will have a second presenter, a second keynote speaker in this session. So I would like to invite Ibu Lilian. Ibu Lilian, could you hear me?
Yes, I will try to share the screen.
Before we started, I would like to read the CV of Ibu Lilian. Okay. And
Do you see my presentation, Dr. Wawa?
Yeah, I can see it. Yeah.
Perfect.
I will read your CV first, Lilian. Yeah. Because Ibu Lilian Gerling has many of the research together with us, especially, and also with the education part, also with the Netherlands and ITS. And Ibu Lilian Gerling right now is a senior lecturer and research at the Delta Academy, Hogeschool Zeeland University of Applied Science in Netherlands. And she is a coordination internationalization Asia and US, and a senior research and lectures in Delta and water management. And she also has so many projects in Indonesia, including development of living lab water in Surabaya with ITS, especially for resilient coast Surabaya. So Dr. Lilian, I will give you the time and also the screen. So please, you can start.
Okay, thank you very much, Dr. Wawa. Good afternoon, and thanks for still joining, and thank you for the invitation of having me today. I'm delighted to be able to speak from so far away in an also more sustainable way, although I really like being with you, and of you, of course, your kindness and your lovely food. But I have in my mind, sea is the other side of the ocean, where Dr. Thomas was just talking from the other side. Our University of Applied Sciences is in the southwest delta of the Netherlands. And you see, of course, the Netherlands have a big coastline, but compared to Indonesia, it's nothing. So it's all in respect. So what I will do is, well, talk about, and what is funny is that what Dr. Thomas just showed you is also what I would like to start off with. What is really striking, of course, is that we've moved now to only the most urgent and pressing issues, both from likelihood, but also the impact of risks to be happening, are all on the green side, right? Interesting. Beginning this year, it was not even in, and probably next year, you already saw in some new presentations of the World Economic Forum, pandemic will surely be in, of course, again. So yeah, I will skip this one because you just heard that story, but I think it's important that, of course, biodiversity loss, the most urgent pressing issue. At the coastline of our small country, the Netherlands, what is a striking fact is that most of our current nature areas are at sea. So the sea is very important, but you will see also that our coastline have the most nature areas. Of course, we also have some land, but well, we shrink that on a large account. And we do not fit also here that we need actually. So what we just said, that biodiversity is declining on a global scale, is also happening in the Netherlands. And to have that, we know that connections and surface are very important, and surface is in the Netherlands, that connections and is that we don't have enough. So here you see this comparison between how the world is going down very bad. And of course, there are many issues regarded to this aspect. And why is this going not so well with our biodiversity in the Netherlands? Well, of course, we have intensified our agricultural production a lot. We are the second largest food exporter globally. So that's weird, right, from such a small country. Part, of course, is also based on that we import half products and then we further process them, but also we produce a lot. We drained a lot of our wet areas. We use a lot of course, artificial fertilizer. We have unsustainable fishing, overgrazing, invasive alien species due to this global connectedness, of course. So yeah, we have hardly any pristine areas left. But in our coastal area and at sea, of course, that's still very important. On top of that, enormous biodiversity loss within our country, we also have the effects of climate change because we are a very low-lying country, probably you know that. The biggest part of our country is below sea level. I grew up in an area that was -6 meters below sea level. So yeah, there are some challenges from that perspective. So if you take these very specific with the climate change projections, so what it means really if we get warmer and then make all those relationships to see how it will affect not only the water production, the food production, but also, of course, the overall feeling of people, the health of people, etc. People that are from landscape architectural offices or sustainable planning offices. What do you think could happen to the Netherlands in the long-term future? And we make this kind of scenarios. Now look at this map carefully. So would our country be lost? Our biggest economic zone is in the western part, but actually in that part, yes. And of course, then only here we have the higher placed area. So our economic center would completely be vanished. So yeah, we could either protect these by having extra high dikes and give the rest of the delta back to the sea. So extra high dikes and give the rest sea. Protect the delta back. That could be one aspect. If you go back in time, you would see that, oh, it's almost similar a long time ago. So we added land, we added huge amounts of lands we reclaimed from the sea, from marshes, from lakes and swamps. So our country is almost 1/5 area bigger than it was once when it was still in a pristine state. So this seminar of today is focusing on coast and coastal sustainability. So there's a lot on how can we make our coast more part of this urgent pressing topics of climate change, but also and related to that, of course, flooding from that perspective for the Netherlands, also to the biodiversity loss. And can we have another approach than we have been using over the past, well, 700 years, if you look at the Dutch coast, because we are working on our coast for quite some time now. So you can divide from the landscape perspective our coast in three areas. So the barrier islands in the north, and then you have an interrupted row of dune area, and then we have our delta in the southwest part of our country, our delta coast. We still loves the islands, although you can see in this slide, and probably many of you know, that we have also closed it off for a big part to already prevent more floods that we had in the past. So yeah, some parts of our coast still look very pretty and pristine, although of course we all work on them. You'll see that also our seascape is already changing. We need sustainable energy, so you see more and more recently being built up new windmill parks at sea. And this is the northern part, and this has been attributed to the UNESCO World Heritage Sites since 2007. And which is very special of our northern coastal part is that you have the tidal influences. So when the seawater is low tide, you can walk from the land via the sand flats towards the island, which is a nice way of spending your holiday. Of course, you need a guide because it can be dangerous as well if you don't know where to go. So yeah, those areas are very important for birds, for all kinds of animals, but also for us human beings, of course. So like I said, we have also protected some of these coastal areas. One is in the UNESCO World Heritage, but you also have some national parks in those areas. And we see even opportunity to make our southwestern delta also a more protected area for the long-term future. And although with the pictures you saw on the previous slide, you might think that it's still quite natural, well, we have attributed many infrastructural works to our coastline to be really safe. So now next to this row of dunes that we have, we also added a lot of sea dikes and seawall elements and also storm surge barriers to keep flooding out of the country. And we have this constant play of erosion accretion, and actually we do not have enough accretion. So based on that, we need to put a lot of sand on our beaches. So due to this coastal erosion, which is mostly taking place in this month that we're now speaking of, when we have the storms in the Netherlands, so from November to February, you see that parts of our coastline disappear, the soft sandy parts. So therefore we have this sandy strategy, and we need an enormous amount of cubic meters of sand every year to maintain our coastline at the safe side. And of course, these coastal nourishments, they cause not only CO2 emissions, but of course they have many, many, many downsides for the marine ecology, for the seabed, etc. And our main planning agency, the Rijkswaterstaat, they also said that we have to be climate neutral by the 2030. So we really need to implement fundamental innovations in this coastal replenishment. On top of that, of course, one of the elements that we are worried about, all those countries are using sand for their building industry, etc. There will be also an ending of that product. So we really need to carefully rethink what we're doing there. Of course, to keep the sand, we have this type of strategy as well. We put in all kinds of groins and other elements to at least prevent either erosion or sedimentation in places where we don't want it. And like I just said, we've built some enormous infrastructural works to keep out the sea and to keep us safe. This is an open barrier, partly open barrier, so we still have the saltwater entrance, which is very important for the fishery in the estuary behind it. And we have a bigger structure built in 2007. These are the size of 2 Eiffel Towers. So you have a kind of idea how enormous big structures these are. And we test that every September to see if it still works. Sometimes we use it. Now it's only once a year, but in the future with sea level rise, it could be that we have to close it more often. And that of course would have also a very negative effect on the navigation, because the main navigation channel is this one. So you can imagine, so for the rest of Europe, that this is one of the main entrances to go to the backland is very important. So yeah, we kept our country safe until now. We made it economically optimal, but it had a lot of downsides. So we need to change, and we need to start reconsidering how we work with our coast. And we need to do that on ecosystem-based design. Another word is also used for that is the building with nature approach. Connected to that, I would also like to point out that many cities already, but also the national government has now embraced this idea of the circular economy. And I actually more in favor even of the donut economy. So you see on the outside of this donut, you see that all those areas where we are in danger. So there's the nitrogen and phosphorus, of course, loading. It's the chemical pollution, it's climate change. It's also still ozone layer depletion, the acidification of our oceans, air pollution, biodiversity loss, of course, and land conversion, everything that Dr. Thomas also talked about in the previous speech. But we need to connect that, of course, to our social foundation. So the social equity, gender equality, housing networks, etc. And all the things that we design should be in this donut. And only then we could have a sustainable country, but also a good and decent economy based on our natural ecosystem services. And we will no longer hopefully use more than one planet per year. I mean, our country was already in May having their footprint completely used. So we are already in this extra time for more than half a year, which is not good, of course. So to do this, to reconsider our coast and this building with nature approach, of course, you first need to understand how the system is functioning. Literally, the spatial system, the hydraulic system, the geomorphological system, etc., but also connected to that, the social system and the government system. They are all connected. And then, of course, you need to see what are the functions that you need and how can we make the process better and make use of the natural processes to stimulate those goals that we like to have. Can we get the support from our government systems? And of course, very important when we try these new things, we need to monitor them very long time, also after completion, and to see in the long term if it will work. Well, this is already a bit different approach we start using when we made this new port. This is the largest port of Europe. It's the port of Rotterdam. It's at sea. So what you see, of course, is a land reclamation. And making these in itself, of course, is not a very sustainable thing to do always, because you need the sand to make it. But during the dredging of the sand, they tried already to do it with less harming the sea floor. So they tried to not scrape everything out in all of a sudden, but they experimented already with thin layers so that the benthic environment, the life at the sea floor, could restore more easily. Another way that we try now, and you've probably heard of this one as well, we call it the sand engine or sand motor. It's close to The Hague, and here's this area where our dune is not safe enough. There's this weak link in our dune system. So therefore we need to dredge a lot and put sand on the beach, which is, well, I just said that, bad for the environment, for the ecology, but also during the holiday season could disturb tourism, etc. So what they tried is, and this is still, of course, under monitoring, there are many PhD trajectories connected to this one. They put one pile of sand in front of the coast and let now the wind process it. And you see this, the shape is also evolving over time. So you have a whole publication that you can download for free via this link. And there are also very interesting movies that you could see about this whole development and how it evolves over time. So if this is going to be successful, we can implement this, of course, more often in the future, or other countries with a soft, sandy coastline. Connected to this one, there are more innovations currently under research by the Rijkswaterstaat. One of them is, for instance, instead of having the big boats, using the windmill at sea to bring the sand towards the coast, part of the coast that you will need it, to have less CO2 emissions instead of the dredging that causes a lot of CO2 emissions. And another one would be also, this is a new innovation under research, putting a kind of wing on the seafloor that will guide the sand towards the direction where you need it. So to help a little bit of this natural flow, this sedimentation toward the direction where you need it the most. Another one related to this sand engine is taking place in the northern part of our country, where you have the barrier islands. There we have also some weak links. So we have sea dikes, as you can see on this picture. So on the left side, you will see the sea. And what they did is they make this inner sea where the sea flood can go in. They added an island to that so that the birds can nest there. So when they make this new thing, they directly think about nature values and do this at the same time, which is already a great improvement if you compare this to how we used to construct this type of things, let's say 40 years, 20 years ago. And then we make these areas over here. You see them over here. So the sea get in and they bring in the sea clay, the sediment, and then they have different types and they let it dry in different ways. And then they can directly use that clay, this ripened clay or sediment, on the sea dike. So instead of bringing the clay from another area with trucks, which would be expensive, but also, of course, bad for the environment, again, CO2 emissions, they try to harvest it in this way and to see if they can widen and heighten this dike in this way. So we keep up with sea level rise, but in a more natural way. So we harvest it directly by just using the force of the waves, the currents of the sea, which is, in my view, a big improvement. So this is under research at the moment. Similar type of thing they try to do also in this northern part of the country to a port of Harlingen, small port close to Germany, where they also try to develop the salt marsh in front of the area. Like you are trying to restore mangrove in many areas, salt marshes, and other type of forest. For our country, of course, it has the same influence. It safeguards your coastline, and it's very good for the ecosystem services, for the fish, for the birds, etc. So this mud motor, all those benefits, of course, you have less recirculation towards the port that you have, less maintenance and dredging. You have a stabilization of your foreshore, of your dikes, so less maintenance work on the dike itself. And also this type of projects, you cannot do it by yourself. So you have the EcoShape consortium where many infrastructural and engineering agencies from the Netherlands are connected to, but they also work together with the local government and with local nature organizations. So this collaboration, this sharing of knowledge and together monitoring is of course very important with this type of new ways of going forward. And here you see kind of our mangroves in the Netherlands. So we also try to restore along our inner lake, the big fresh lake inside our country that was formerly sea, to see if that could also help not only for flood, but also, of course, this supporting the ecosystems. Now, going back to our province, where our university is located, you will see that also here we have a big, actually, living lab all around us. So that's the big advantage of being close to an area where you can really do the research in the field. And it's also very nice for all our students because all the students can also help in this ongoing type of research. So for instance, also here we look into can we restore salt marshes by using a specific type of plant, in this case, cordgrass. And we do all kind of, we choose areas and then we experiment with either already putting it on mats and putting it in place and to see how it works, if it can regrow, etc. This is all ongoing, so it's still under research. And very interesting thing to see if it will work on the long term. Another ecosystem engineer that we are looking into to see if it could be beneficial is using oyster reefs. We have a lot of sand hunger in our eastern schelp because we put a storm surge barrier in front, and those tidal flats are disappearing. And it's very important to have these tidal flats for the local biodiversity again, because they are used by all kind of birds and all kind of other small animals. So to restore those tidal flats, we see if we can use oyster reefs. And this is also a very interesting, successful experiment that we do at the moment. So to help, I just say, prevent this net erosion. So these oyster reefs, they will dissipate the wave energy and they will trap the sediment on the landward side and hopefully halt this erosion of the tidal flats locally. So that's also what we monitor. And we make also communal presentations about that. And we also use, like I just said, a lot of our students in this ongoing research. So they help us go in the field and monitor all those type of structures, the size, where they are, etc., what's happening, which is very nice. Another thing that we are trying at the moment in the Netherlands, instead of making new land reclamations, like you saw we did a lot, deep poldering, so giving pieces back to the sea or to the river. So this is a very new recent trend that we have been applying since a few years and that we are still applying. I heard that you shared the video, so I'm not sure if it will work to open it. So to make it less complicated, you can later watch it. But what we do is we take out the right dike, and then the sea will get in this area, whereas the area behind that is still protected, and this area will be given back to nature. So this is one of the polders that was once rich farmland, of course, but we gave this one back already and made this again a nature area. And here you see how it's looking now when it's flooded. So these houses are still there. The people decided that they want to stay because this is not 24/7 and on a weekly basis like this. This is only once a year that it's this high water. So last year we also had it in January. This was from 2018, but they are all on turbs, those houses. So they're still safe. But what needs to happen, because in those now nature areas, we have cows walking around, wild cows. We have all kinds of other animals, hares and deer, etc. And they are evacuated because we know when we have these high water levels. So the first 3 people evacuate the people from that nature area before they let the water go in. And the same will happen with an area in the province where our University of Applied Sciences is. And we are also, one of my colleagues is involved in this ongoing research. So here you see it was still sea, and then we start reclaiming it. So we made additional land, as you can see over here. A big polder, and part of it is in the Netherlands, and part of it is in Belgium. So it's a cross-border project. You see it on the right-hand side on the top picture. So what we do now is give this back to nature. And it is also to, because the port of Antwerp needs the river, the Scheldt to the port of Antwerp need to be dredged, causing again a lot of downside. But of course we cannot say just let Antwerp be like what it is. They like to have their port function. So the Belgian and the Dutch government collaborated on this one. And they have to compensate for the loss of nature due to this dredging of the river. And they compensate here in this place, in this specific polder, and give it back to nature. Of course, the farmers were not very happy. They protested fiercely, up to the highest level of protest within the European Union. But eventually it was decided, and well, there were not enough decent arguments. They got compensation, of course, for the loss of their area. So that's been done a decent job from that perspective, but it's more a cultural aspect. So you need to consider that as well if you start doing this type of experiments. That of course the land, specifically in this province, it was flooded so often, this delta area, that you reclaim land from the sea. That's also in the sign of this province, that you see the line resting itself from the sea. That is so culturally important for the people, and then give it back to the sea. So the more older farmers, they're not used to doing that, and they say we cannot just give it back to the sea what we gained. But well, in the future they should get used to that we should do that more often. So this area you see already also foreshore marsh occurring. Here you see the high sea dike, and this area will also be flooded many times of the year. So a bit a little bit inland, so just behind our coastal area, what you also see a current trend also occurring in my city of Rotterdam, which is 35, 37 kilometers inland. You see this whole movement of making use of the tides, making use of the natural system. And that's the creation of tidal parks. So this asks for a new type of landscape, new type of vegetation, but it will surely help to restore again also the water quality in the river, also that the people understand this whole tidal system way better. And it also will contribute, of course, to again restoring ecosystem services that are delivered by the river.
Dr. Lilian, you have 5 minutes more for the presentation. Yeah.
Okay. So here you see all those benefits that we have when we start creating those specific new type of river landscapes. So connecting the city and the river better, you offer a learning environment quite close by, you increase the biodiversity, you could even have food production, etc. So here you see all those areas where we try to do this inside, and here is a place in the big river where they restore the natural area, but they also look at the land part that are connected to it and how to develop these type of tidal parks and how does it also really fit in the local context. So some have more natural shores with some cultural elements and vice versa in the city area. You have more cultural shores, but of course we try to make them more natural. So here you have an example in the city of Schiedam, where they have the same type of experience that you could have in the northern coastline. There's this muddy area where you can just go hiking and have this special experience. And it also creates new nature, new type of forest close to the city where people could also go for recreation. And also in our province, we have this big coastal laboratory. It's called Waterdune. So a new area that's also made with an area that can flood, so the salt water goes in. And we create there also a new area for aquaculture, but also tourism. So it's also an area where the tide really have free game, and it also offers new type of agriculture. So farmers are now trying to experiment with all kinds of saline crops. So they also adapt to this new salt environment instead of trying to keep the salt water out. So making beneficial use of it. And to conclude, I already said the monitoring is quite important. So another thing that we involve our students in, and we do a lot, is also looking into the marine litter using the OSPAR method, mapping our beaches, seeing what comes out, who is causing the damage. And we also test all kinds of other apps in doing that. And what we see is that most of the pollution that ends up on our beaches is coming from the fishery and the fishing industry related to it. So it's the dolly rope, it's from fishing nets, next to, of course, all kinds of small plastic elements and on beaches left by tourists, of course, and food and candy wrappers. So this is doing a lot of hurt, and unfortunately it's still allowed by the European Union that Belgian and Dutch fishermen can use this type of rope that they connect to their fishing nets, causing a lot of damage to the ecosystems at sea. So I hope they will really forbid this, and that we cannot use plastic just to make the fishing go more smoothly, and we are too lazy to repair our fishing nets because that's the only way that we use it for. So can we have a sustainable coastal future? Yes, I think we can. You see one of the other scenarios that is made for the future of our coast, one with additional islands. We never know, we have to experiment, but by showing some of these experiments to you, I hope you get excited as well, try to come up with new ideas and dare to experiment, but monitor carefully to see if it works. And thank you very much for listening. And if you have any questions, please feel free to ask your questions. And thanks for listening.
Yeah. Thank you very much, Ibu Lilian. Hope that next year we will have collaboration research together to check the solid waste in the coastal area, especially using your application. So we have several questions for Professor Thomas and also Ibu Lilian. I will be share the question from the for the audience because we have several questions. So the first one is to Professor Tom. Ibu Afifa from NCKU asking about the coastal zone, which basically was aimed as a mangrove forest, but then they are changed to become a fish pond. So what is how we deal with this one? Because especially in many of the area around the world, they have this kind of problems that change the mangrove forest become a place for fish pond or aquaculture.
Yes. So this is a very important point you make and a very important question, because obviously in a world where we are moving foods across continents, and we in Europe are certainly part of this negative trend, it's a major challenge to actually cultivate at the scale needed for the world shrimps and things like that, mussels. And that typically happens in coastal regions in the tropics, across the tropics actually. And the fish cultivation culture, of course, provides food for the world, not only locally, more important for the world actually, but of course it has a very negative impact on the local environment and the people and the ecosystem living in that environment. And we need to find a balance of something which is globally acceptable in terms of food supply from the ocean, fish supply or shrimps and whatever it actually is, and using cultures without destroying the local environment. And that is a very, very difficult subject area, because a lot of income and a lot of wealth comes actually from these coastal regions where large-scale, industrial-scale fish ponds and agriculture systems are set up to deliver the global market. And we need to find a balance and we need to make a joint decision what is actually acceptable in terms of using these tropical forest regions, coastal regions for aquaculture activities to serve the world, and at what point is that no longer sustainable? This is an open discussion. There is no clear decision yet, because it's a question between people, society, economy, and of course global trade. So it's a very, very complex question. There is no simple answer to that. And but it needs a solution which is more embedded in the strategy moving forward globally. It has to be part of a global strategy which to some extent allows the use of these mangrove forest regions in the tropics, but probably not at the scale as we see it now developing in some regions, where basically whole landscapes are destroyed for the sake of economy, food supply, ultimately seafood supply. And of course, at the local scale, this has an extremely negative impact on the people and the environment at the very local scale. So if we need to find a joint agreement, what is acceptable and what is not acceptable, and what kind of countermeasures could we put in place to keep our coastlines safe. And we have seen in the example before, I mean, the Netherlands is of course probably one of the best examples in the world, being pretty much underwater without all these measurements. How can you design a new country which accepts this situation but still moves forward in a positive way? So the issue about aquaculture in coastal regions, especially in the tropics, is a very, very political one. It's one about big business, really big business. We should here in Europe, where I'm sitting, not complain, because here in England, where I am, the people really like the nice seafood from the southeast. So we are basically benefiting from the damage which is made over there in Southeast Asia and elsewhere. So we need a global answer to this problem. And at the same time, of course, we need to make sure that at the local scale, the fish farmers and the people living down there actually see a future for their own development. And that is something where there is no simple answer.
Okay. Okay, so
I would
thank
say
you,
that
Professor.
the example on Java that you have in the MAC is of course a good one that you have nearby on your own island, but it at least shows that you can restore mangrove areas in a nature-friendly way. And of course, the experiments that have been executed with silvo fishery, so combining it smaller scale, but of course you would have less yield, less output. And yeah, of course, you need to divide it equally. The people that lost job will lose their job, sorry, in the Southeast Asian region can be compensated with something else.
Yeah, yes.
Yeah, discussion of equality, of course, is at the bottom of everything.
Yeah, yes. Thank you, Professor Tom and also Ibu Lilian. And the last question is from the Pak Mario, no, about the climate crisis strongly show they're connected everywhere. But the question is, where is critical? Where's the part is critical? Maybe both of you can answer this question. Yeah, where is the critical point that is mentioned by the climate, because they are strongly connected in many different aspects of our life, especially.
Yeah, I think. Yeah, I think.
If I can, I think we need to find a new balance. We need to find a balance which allows us people to live on the globe, but more in harmony with our environment without destroying that. And of course, whatever we will do, we will have a negative impact. There's no question. But it's defining a new global agreement. What impact is acceptable? Where can we minimize impact? How can we safeguard our climate? Because we are all breathing the same air. So it doesn't matter where we are on this globe. And how can we actually safeguard our environments in their unique roles, which they have, something we call ecosystem services. So I think it's a very, very difficult question, and there is no simple answer. But on the positive side, there are thousands of fantastic and great ideas out there in the world. So many people have good ideas. The problem is many of them are still at the pilot scale. So they demonstrate locally, yes, it works. And that is very, very promising. So the next challenge is then now how can we put all these good examples, and we've just seen one great example how maybe the Netherlands, as a relatively small country in Europe, could possibly develop in the future, being faced by sea level rise and all challenges. But I mean, how can we tie all this together in something which allows to meet the United Nations SDGs, get people out of poverty, these very, very important questions about society, but at the same time not destroying the earth on which we are living. And there is no quick win, that is for sure. So there's always a trade-off. Whatever we do, there's not going to be glorious. It's going to be maybe overall positive, but we need to find a balance, and we need to know where the bottlenecks are.
Okay. Yeah. Okay. Thank you very much for Ibu Lilian and also Professor Thomas. We already finished our session for this keynote speaker. And before we are finished, so we would like to share our gratitude to you, even you are very far away from us in here. So the first one is okay. Could you see my screen?
Yes.
Yes.
Yeah, okay. So this is for Professor Thomas. And then the second one, I can show you for Ibu Lilian. Okay. Thank you very much for today. And it's a very good day for all of us. And we can share our knowledge together. And then before we go to the closing ceremony, we would like to take a picture together, because in the morning session, you not together with us. So please, for all of the participants that's still in this main room, could you open your video? Turn on the video, please. Yeah. we still have 95 of participants is still allowed. Okay, so Ibu Nisa, could you take a picture for them? Okay, so please, first slide and then the second slide, because we don't know where we are in which slide. Okay, so then the third slide. Okay, the last one, fourth slide. Okay, thank you very much for all of the keynote speakers, especially for Professor Tom and also Dr. Lilian. And we will be goes to the closing ceremony. And I would like to invite our Director of Research and Community Services of ITS, Bapak Dr. Agus Muhammad Hatta, to have a closing remark. So, Pak Hatta, time is yours.
Thank you, Ibu Warma. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, the honorable keynote speakers, Professor Thomas Wagner from Heriot-Watt University, United Kingdom, Professor Kensuke Fukushi from the University of Tokyo, Japan, Professor I. Ketut Priya Utama from Institut Teknologi 10 November, Indonesia, Dr. Lilian Gierling from HZ University, Netherlands, and Dr. Aji Pamungkas from Institut Teknologi 10 November, Indonesia. Distinguished guests, ladies and gentlemen, I believe that during this long and busy day, all of us have obtained a fruitful discussion. In this international conference on sustainable coastal management 2020, we have learned a lot from the keynote sessions delivered by the amazing keynote speakers. Once again, on behalf of the committee, thank you for delivering such important materials so that all of us can deepen our knowledge about sustainable coastal management and its related issues. Furthermore, I would like to thank all presenters and participants who have joined this conference from all over the world. I sincerely hope that through your presentation and discussion afterwards, all of us can contribute to solving the coastal management and resilience problems in our own countries. I would like to thank all committee members, the synergy from Research Center on Marine and Earth Science and Technology, Research Center on Mitigation, Disaster and Climate Change, Research Center on Infrastructure and Environmental Sustainability for organizing this conference and ensuring that it proceeded smoothly. I would like to apologize for any inconvenience that you may experience during this conference. Ladies and gentlemen, there is a saying means when there is a meeting, then there will be goodbye. So I thank you again for your participation and wish you safe and healthy condition during this COVID-19 pandemic. Thank you. Finally, by saying Alhamdulillahirabbil Alamin, praise be to God, we close the International Conference on Sustainable Coastal Management 2020. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon.
Thank you very much for Pak Hatta and also all of the participants. And then
the International Coastal Management. Salam.
So thank you very much for all the participants and also especially for Professor Tom and Ibu Lilian. It's come from far, far away. Okay. Collect the full papers and send to our emails, and then we can publish in IO proceedings as soon as possible. Thank you very much, and thank you for all of the participation today, and hope that we can.
Iya.
Thank you very much. Thank you. Bye-bye.
Iya, putus-putus.
Thank you very much. Thank you. Bye
For
bye.
in this conference especially, and we will listen the
Okay. We will send the certificate
week from now,
2 weeks from now,
we really hope
and then also we really hope that
Suaranya kurang jelas.
for all of the presenter authors today, you can send the full paper directly to put everything for full paper, especially for your full paper in as soon as possible to our email, and then we can publish in IO proceedings conference as soon as possible too. And thank you very much for joining, and thank you very much, and all
Thank you, everyone.
participants. Thank you.
Thank you.
Thank you, everyone.
You may leave the room.
Thank you. Thank you very much, participants.
Thank you, everyone.
Thank you very much. Thank you. Pak Hatta, terima kasih. Pak Haji, terima kasih.
Terima kasih Bu Pak Atta, terima kasih.
Terima kasih. All of friends from Philippines
Pak
that
Bos
still
Nur,
in this room.
serius
Thank you.
terus Pak Bos Nur.
Thank you, everyone. The excellent
Thank you.
organization.
Thank you,
Bye.
Thank you, Dr. Lilian.
Thank you, Dr. Lilian.
Thank you.
Bye, everyone.
Thank you. Thank you Bu
Bye.
Lilian.
Bye.
Have a nice rest.
Yeah,
Yeah.
thank you.
It's been very long day.
Yeah, you had a long
Terima kasih,
day.
Pak Hatta. Terima kasih. Thank you.
Bye-bye.
Bye-bye.
Bye-bye. Thank you. Thank you. We end our meeting. Thank you.
Save chat. Okay. Thank you, everyone. We are going to close the Zoom meeting now. Thank you for your participation.